In this question, if we are given a frequency table, like so, where our data is grouped, to calculate the mean, we need to add 2 extra columns to our frequency table. So the 2 extra columns that I'm going to add, one of them is going to be called the midpoint, which is M, and the second column is the midpoint times the frequency. The midpoint is going to be the midpoint of the interval. Now remember, these groups are called the classes. So the midpoint of 0 to 10 is going to be 5. The next midpoint from 10 to 20 is going to be 15. The next midpoint is going to be 25, and the final midpoint is going to be 35. The M times F column is the midpoint times the frequency column. So we can work those out. So the first one will be 6 times 5, which is 30. Next one, 10 times 15, which is 150. 19 times 25, which gives us 475. And finally, 15 times 35 will give us 525. Now, to get the mean value, we have to take the total of the M times F column, and we have to divide it by the total of the frequency column. So we need to work out this total first. So if we just add up the values in that column, 30 plus 150 plus 475 plus 525, we get 1,180. If we add up the frequency column here, we should get 50 people. And the mean time taken, will be the total of the M times F column, which is 1,180 divided by 50. Now, get into the habit of always putting your answers to 2 decimal places if they come up. So this is going to give us 23.6. We don't need to put it to 2 dp here. We can just write 23.6. The next question is a standard way of doing a division. The first thing you need to do is you need to convert these mixed numbers into top-heavy. So 2 and 4/7, the way to work that out as a top-heavy fraction, 7 times 2 will give us 14, plus that 4 will give us 18. So that becomes 18 over 7, divided by, and then to convert 1 and 1/8 into a top-heavy fraction, 8 times 1 will give us 8, plus 1, which is 9. That's going to give us 9 over 8. We do not need to do anything with the answer. The reason that this question is giving us the answer is because they explicitly want us to show the working. So by doing the first calculation here and converting these into top-heavy, that's going to get us 1 mark. Now, the way you do divisions, you keep the original fraction the same. You change the divide sign to a multiply sign, and you need to flip the fraction 8 over 9 over. So this becomes 8 over 9. And you need to show the next bit of working. When you multiply fractions, you multiply straight across. So numerator to numerator, 18 times 8 over 7 times 9. You need to show this stage in the working. Equals, we can do it on a calculator, 18 times 8 will give us 144, over 7 times 9, which gives us 63. We can now type this into the calculator to get our answer. 144 divided by 63, that simplifies down to 16 over 7. And that is going to be equal to 2 and 2/7, which is the answer that we had here. The way that we go about factorizing these harder quadratics, and the only reason we call it a harder quadratic is because we have this 2 in front of the x squared term. The first thing we do is we multiply the 2 by the number at the end. And we drop the 2 in front of the x squared term. So we end up with x squared minus 7x plus 12. Now this is a fairly straightforward normal quadratic expression, and we know that this is going to factorize into 2 brackets. So what I'm going to do, I'm going to put my 2 brackets in like so. I'm going to put an x in each bracket. Now the way that we factorize a normal quadratic is we want 2 numbers that multiply together to give us plus 12. And when we add the same 2 numbers together, we have to end up with this minus 7. Now, because this is a plus and this is a minus, both of the numbers have got to be negative. So the only combination of 2 numbers that do that will be minus 3 and minus 4. We can check. Minus 3 times minus 4 will give us plus 12. Minus 3 plus minus 4 will give us that minus 7. Now, to take into account of that 2 that we multiplied at the beginning, we put it back into our expression by putting it in front of each of the x's in each bracket. And then we look at each bracket and see whether we can cancel. If you look at the first bracket here, there isn't a whole number that goes into 2 or 3. So we can't cancel that bracket, so we just keep it as it is, 2x minus 3. If we look at the second bracket, well, there is a number that goes into 2 and 4. We can divide everything here by 2. So 2x divided by 2 will just basically give us x. And then minus 4 divided by 2 will give us minus 2. And what we end up with is our factorized expression, which in this case is just 2x minus 3 times x minus 2. Part B is an algebraic equation which has this fraction in it. Now, the way that we deal with algebraic equations with fractions, we get rid of this divide by 3 first on the left-hand side. So the first thing we're going to do, we're going to get rid of this 3 by moving it over the equal sign. Now, what happens is that when we move this divide by 3 over the equal sign, it becomes a multiply by 3. So everything on the right-hand side of this equation is going to be multiplied by 3. And the way we write it, well, when we move the 3 over, we're just going to be left with 4m plus 9 on the left equals, and now remember, we're multiplying everything on the right-hand side by 3. So we put the 7 minus 2m in a bracket. We put the 3 in front of it. By doing that, we've got rid of the fraction on the left. Now, this becomes a normal straightforward equation where we have to multiply out this single bracket on the right. So if we go ahead and do that, we're going to get 4m plus 9 equals 3 times 7 is 21, minus 3 times 2, which is going to give us minus 6m. Bring all the m terms over to the right. And anything that doesn't have an m in it, bring it over to the right-hand side. So we're going to get 4m plus 6m equals 21 minus 9. That's going to give us 10m equals, and then we can work out what 21 minus 9 is. That's going to give us 12. Then bring the 10 over. M is going to be 12 divided by 10, which gives us 1.2. So the solution is just m is equal to 1.2. Now, I've laid out all the steps here so you can see them clearly. In practice, if you want to take shortcuts and you're confident about doing this, you can. Part C, it looks complicated, but they want it also in this form y to the power of b. Now, the way that you go about doing this question, it's understanding what this actually means, the fourth root of y. Now, you need to remember that we can write the fourth root of y as a fractional power. We can write it as y to the power of a quarter. That's really what this question is asking you to understand. that if we've got a fourth root, we can write it as a fractional power. Now, if I rewrite the original expression, the fourth root of y can be written as y to the power of a quarter over, and then we're going to have y, but remember there's a hidden 1 on the y at the bottom. So that y, there's a hidden 1 there. It's y to the power of 1. Now this becomes a little bit easier to deal with because you have to remember that when you divide terms, if you've got the same letter in each case, the base is y, all you do is you subtract the powers. So your final answer is going to be y, and then if you subtract the powers, 1/4 take away 1 will give you -3/4. So your final answer is going to be y to the power of -3/4. And they want it as a fraction, so leave your answer in that form. With this straightforward linear equation, we notice that we've got a bracket on the left-hand side. So we start by multiplying out the bracket first. So 5 times 4 and then 5 times minus x. So if we multiply out the bracket on the left-hand side, 5 times 4 will give us 20. And then 5 times minus x will give us minus 5x equals 7 minus 3x. Standard equation, we basically bring all the x terms over to the left, and anything that doesn't have an x in it, we're going to bring it over to the right. So on the left, we're going to have minus 5x plus 3x equals 7 minus 20. Minus 5x plus 3x will give us minus 2x equals minus 13. Now, because we've got negatives on both sides of the equation here, we can basically just get rid of them. So we can just write this as 2x equals 13. Bring the 2 over, so x will be equal to 13 divided by 2, which gives us 6.5 as the solution. The next example is a simple factorization. It's a simple factorization because it's going to go into one bracket. We know that it's going to go into one bracket because it's not a normal quadratic expression. It's not going to be the difference of two squares because this is a plus and not a minus. So it's going to go into a single bracket. So what we're going to do, first of all, put a bracket in and then close it like so. Look at this 16 and the 24. We want the largest number that goes into 16 and the 24. The largest number that goes into 16 and 24 is 8. So I'm going to take 8 outside the bracket first. You're then going to notice that each term has an m common and it's got a g common. So we're going to take, first of all, the m outside the bracket. And the power that we take, we go for the lowest power on the m. So we've got m to the power of 3 here, we've got m to the power of 2. So we take the lowest power of m outside the bracket. And we're then going to look at the g. The g is common to both terms, and we take the g with the lowest power. In this case, it's to the power of 3. So outside the bracket, we're going to have g cubed. Now to figure out what goes inside the bracket, look at the first term. 8 goes into 16 twice, so we put the 2 down first. Then we look at the m. We've got m cubed here, which basically means we've got 3 m's, but we've taken 2 of the m's out, so we're just going to be left with 1 m inside the bracket. If we then look at the g's, we've got g cubed, which means we've got 3 g's here. We've taken 3 g's out, so we don't have any g's in the first term inside the bracket. We then put the plus sign in from here. 8 goes into 24 3 times, so the first part of the second term becomes 3. If we look at the m, we've got m squared here. We've taken 2 of the m's out already, so there's no more m's left in the second term. We've got g to the 5, which means we've got 5 g's. We've taken 3 of the g's out, so we're just left with 2 g's inside the bracket in the second term. And that is our factorized expression. Part C, another factorization question, but again, you need to recognize this as a normal quadratic expression. It's a normal quadratic expression because you've got the y squared term, you've got a y term, and you've got a number term. Now, with these normal quadratics, we know that they're going to go into two brackets, so we can put two brackets in automatically, and we can put a y in each bracket. Now, to figure out the numbers that go inside the bracket, which have to be whole numbers, we're looking for two numbers that are going to multiply to give us 48 or minus 48. And when we add those same two numbers together, we need to get plus 2. Now, the only combination of numbers that multiply to give us minus 48 and add together to give us minus 2 will be 6 and 8, minus 8 and plus 6. And we can double check. 6 times minus 8 will give us minus 48. Plus 6 plus minus 8 will give us that minus 2. So we end up with our factorized quadratic expression. Now, part 2, you have to be very careful here. They're using the word hence, and hence means that you have to use the answer above. So there was a reason why they asked us to factorize this quadratic expression, because if you look here, it's the same expression, but it's now equal to 0. So this is now a quadratic equation. So the first thing to do is to use the factorized answer from part 1 and replace the left-hand side here with the double bracket. So the left-hand side can now be written as y plus 6 times y minus 8 equals 0. So it's just recognizing that this is exactly the same as what we factorized in part 1. Now, once we've got the factorized expression, to get the solutions, all we do is we make each bracket equal to 0. So we take the first bracket, which is y plus 6, and we make that equal to 0. We solve it like a normal equation, bring the 6 over. So our first solution is going to be y is equal to minus 6. We then do the same with the second bracket, which is y minus 8. We make y minus 8 equal to 0. We then solve it, bring the minus 8 over, so we get our second solution, y is equal to 8. Like with all quadratics, we end up with two values. In this case, the two values that we end up with are minus 6 and y equals 8. This is an example of a simple trigonometry question. The first thing to notice is that we're dealing with right angle triangles. We have the right angle triangle ABD and we have the right angle triangle BCD. The first way to tackle the question is basically to redraw the right angle triangles separately. So the question's asking us to work out B to C, which is linked in with this right angle triangle BCD. So if I redraw that triangle and then put in the info I know, well, we know that this angle at C is 90 degrees. We know this is going to be B. This is going to be D. We know that the length from B to C is 8.4. And the length we're trying to calculate is this length X. Now, this triangle on its own, you can't actually do anything with it because we don't know, we only have one piece of information. We just know that this length is 8.4 and this is a right angle triangle. Or a 90-degree angle here. So what we need to do, we need to work out the length of B to D first using this right angle triangle here on the top. So if we redraw that triangle, ABD, we know that this is going to be a 90-degree angle here, which is going to be A. And we're going to put the other lengths in. So we know if this is A, then D is directly above A. So this is going to be D. And then the other point's got to be B. And then we can put in the information we know. We know that A to D is going to be this 3.6. And we know that A to B here is going to be this 9.8. So if I put the lengths in, this is going to be 9.8. This is going to be 3.6. Now, what you can see immediately is that using triangle ADB, so using this triangle here, we can work out the length of D to B. That length corresponds to D to B in the first right angle triangle we drew out. So we can use Pythagoras' theorem. The length opposite the 90-degree angle is C. We call the other two lengths A and B. And we can just use Pythagoras' theorem, which if you recall, is C squared equals A squared plus B squared. We can work this out. 3.6 squared plus 9.8 squared. Now, I'm not going to work it out just yet. What I'm going to do is I'm just going to do everything in one go. So if I just move this up a little bit, we can then work out what C is by taking the square root of what we just wrote above. And we can do that all in one go. So if I do that in one go, 3.6 squared plus 9.8 squared, and then I take the square root of that, I end up with 10.44, and I'm going to put it to 3dp. And the reason I'm putting it to 3dp, because this is not the final answer. It's part of the answer. So I don't want to round it too much. What I'm then going to do is I'm going to take this length of 10.44, and I'm going to replace it into this right angle triangle, because this length B to D is the same as this length B to D. So this is going to be 10.440. And again, we can use Pythagoras' theorem to work out the length of D to C, or X. The length which is opposite the 90-degree angle is C. It doesn't really matter which length we call A and B, but in this case, because we want to work out B, it's going to be a subtract. It's going to be 10.440 squared minus 8.4 squared. We can do this again in one go on our calculator. And if we just type that in and then take the square root, we get our answer of 6.206. And we can now round it to, say, 2dp, 6.21. The question doesn't mention it, so if the question doesn't mention the number of significant figures or decimal places, we can just generally keep it at 2dp. So our final answer is going to be 6.21. With this question, you're given some statistical information regarding the weight of tigers in this table. You're told that you're looking at 50 tigers. You're told that 22 of the tigers have a mean weight of 260 kilograms. You're given 28 Bengal tigers, but you're not told what their mean weight is. And finally, you're given that all of the tigers have a mean weight of 218 kilograms. Now, the question revolves around you understanding what the mean value actually translates to. So if we look at the Siberian tigers, we're told that we've got 22 tigers and that their mean weight is 260 kilograms. What that means is that each of those tigers effectively weighs 22 kilograms. 260 kilograms. So what we can do is we can work out the total weight of these 22 tigers by doing a simple multiplication. So 22 tigers, each one weighs 260 kilograms. So their combined weight is going to be 22 times 260. And if we work that out, we get 5,720 kilograms. Now, we can't do a similar calculation for the Bengal tigers because we do not know what the mean weight is. But what we are given information about is that we're told that all of the 50 tigers have a mean weight of 218 kilograms. So the total weight of all of the tigers, the Siberian and the Bengal tigers, is going to be 50 times 218 kilograms. So if we work that out, we get a total combined weight of 10,900 kilograms. So we've got two pieces of information now. We know the total weight of all of the Siberian tigers, which is going to be 5,720 kilograms. We know the total weight of the Bengal tigers and the Siberian tigers is going to be 10,900 kilograms. So by doing a simple subtract, we can work out the total weight of the Bengal tigers. And the total weight of the Bengal tigers is going to be 10,900 kilograms minus 5,220 kilograms, which gives us 5,180 kilograms. This value that we just calculated is the total weight of all of the Bengal tigers that we have in our sample. In other words, it's the total weight of these 28 Bengal tigers. Now, if we wanted to work out the mean weight of the Bengal tigers, effectively it's the weight of one of the tigers. The mean weight of the Bengal tigers is simply going to be the total weight of all of the Bengal tigers, which is the 5,180 kilograms we just calculated, divided by the number of Bengal tigers, which is 28. And if we do that calculation, 5,180 divided by 28, we will get 185 kilograms. That is going to be the mean weight of those Bengal tigers in our sample. The first part of this percentage question is fairly straightforward. We want to convert 7 million or write 7 million as a fraction of 32 million, or write 7 million as a percentage of 32 million. So I'm just going to rewrite this. It's 7 out of 32. You don't need to worry about putting in the zeros for the millions because both quantities are referred to as million. So we want to write 7 out of 32 as a fraction. Now 7 out of 32 is basically the fraction 7 over 32. Now to convert a fraction to a percentage, which is what we want to calculate, we just multiply by 100. So if we do that on the calculator, 7 divided by 32 times 100 will give us 21.875%. Now the question wants this to 1 dp, so if we look at the second decimal place, which is the 7, because that's bigger than 5, the 8 has to go up by 1 digit, so our value is going to be 21.9%. Part B, again, we have all of this information given to us. All we want to do in this question is we want to increase 32 million by 4%. Now again, if you look at the answer here, the answer is in millions, so we don't need to put the zeros in. In other words, we do not need to write 32 million with all the zeros. We don't need to write that. So we can basically get rid of it and just use 32 million, or just 32. Now, the original value is 100%, and this is the way that we do normal percentages. We always set the original value to 100%. The original value is the 32 million. Now, we're going to increase that 100% by 4%, which is going to give us 104%. What that means is that the new value, which is what we want, is going to be 104% of the original value, which was the 32 million. Now remember, a percentage is just a fraction out of 100, so I can write 104% as 104 over 100. That's its fraction. And then all I do is I multiply it by the original value, which was the 32 million. And if I do that on the calculator in one go and type it in exactly as I've written it, using the brackets, I end up with 33.28. And that answer is going to be in millions. So we just write the word million next to it. Now the question wants us to the nearest million. So to the nearest million, it's going to be 33, because that's what it's going to be to the nearest whole number. If we look at the first decimal place, that's less than 5, so we don't need to do anything to that 3, which is just to the left of the decimal point. So our answer is just 33 million. The cumulative frequency questions are fairly straightforward. We get the cumulative frequencies from the frequency table that we're given. So we're given at the very, very beginning a frequency table here, and we're asked to fill in the cumulative frequencies. Cumulative basically means to add up frequencies. So all we have to do to fill this table in is we basically have to add the frequencies from the frequency tables given to us above. The important thing to notice is that all of these values here are 0. So the first cumulative frequency, if we look at the table, we want the number of taxi journeys between 0 and 5 minutes, and that's going to correspond to a frequency of 7. So the first cumulative frequency is going to be 7. The next cumulative frequency, we want values of time between 0 and 10 seconds. So between 0 and 10 seconds, it's going to be 7 plus that 10, which gives us 17. And then all we do is we just add these frequencies as we go down. So the next cumulative frequency is going to be 7 plus 10 plus 12, which gives us 29. So 7 plus 10 plus 12. The next cumulative frequency is going to be 7 plus 10 plus 12 plus 19, and that's going to give us 48. 7 plus 10 plus 12 plus 19. The next cumulative frequency here is going to be 7 plus 10 plus 12 plus 19 plus 18, which gives us 66. So 7 plus 10 plus 12 plus 19 plus 18. And then the final cumulative frequency, 7 plus 10 plus 12 plus 19 plus 18 plus 14, will give us the final cumulative frequency, which is going to be 80. Now, I've shown all the additions here. In practice, you don't need to. So you don't need to show all of these additions. You just want to make sure that you've added up the frequencies correctly. And the way you can do a double check is that the number that you get at the very end here, this 80, has to be the total of the frequencies, which is the 80 up there. Now, once you've got the cumulative frequency table completed, the next thing you'll have to do is you'll need to plot the cumulative frequency curve, which is what they're actually asking you to do here. And they call it a cumulative frequency graph. This is going to be a curve. That's the main thing that you need to remember. It's not going to be a bar chart or a histogram. It's going to be a smooth curve. To save some time, I've brought the cumulative frequency table that we had from the previous page and I've just pasted it over here. To plot the cumulative frequency curve, the first thing to notice are the headings. You've got cumulative frequency here on the vertical axis, and you've got time taken here on the horizontal axis. In our table, we've got cumulative frequency in the second column, time in the first column. Again, if you notice, all of these values here are 0. So when we come to plot the cumulative frequency curve, we need a series of points. We're plotting the upper bound, or the upper value, in our class against the cumulative frequency. So the first point that we're going to plot is going to be 5 minutes across and then 7 units up. So the first point is going to be 5 across, 7 up, which is going to be roughly about here. The next point, we're going 10 across and then we're going 17 up. So we're going 10 across on time and going 17 across on the cumulative frequency. So 10 across and then 17 up, which takes us to about there. Our next point, we're going 15 units across, 29 units up. So 15 across, 29 units up is going to take us to some point there. Our next point, so 15 across, 29 up, which is there. Our next point, we're going 20 units across, 48 up, so 20 across, 49 up. It's going to take us somewhere up here. Just above, whoops. So 20 across, 49 up, takes us about there. The next point, we're going 25 across, 66 up, which is going to take us up to around here. And then our final point, we're going 30 across in time, 80 up. So 30 across, 80 up, takes us all the way up to here. So what we end up with are a series of points which, when we join them up together, we're going to get a kind of smooth curve. Now, because we don't have any values which are less than 0, we can take the curve down to the origin where it's 0, 0. Now, if I join these points up with a smooth curve, I'm going to end up with the cumulative frequency curve, which is what we were after. The smoothest possible curve that we can get. The main thing to realize is that this is not a bar chart. Using the graph, we need to calculate first of all the median. Now remember that the median basically is the halfway value. Now from our cumulative frequency curve, we know that if I extend a horizontal line going all the way across, that levels off at a total of 80, which refers to the fact that we had 80 taxi journeys in total in our sample. Now to get the median time, well, we need to work out what half of 80 is. So it's half of the total of the cumulative frequency, which is 80. That gives us a value of 40. So all you do to get the median time is you go up to 40. You draw a horizontal line across to where it meets your cumulative frequency curve. And then you drop a line going vertically down again. If you've got a ruler, use a ruler to improve the accuracy. And that is going to give us a value which is some way there. And if we read this from the graph, we can see, well, that's going to be 17.5. Each of these little squares is a half. So 17.5 plus a half will give us 18. So from the graph, it appears that the median, or the median time, is going to be equal to 18 minutes. And again, it's an approximation or an estimate because we had to read it from the graph. So that, what we just calculated, was the median time. The next calculation, the interquartile range, you need to know the definition for this. The interquartile range is the upper quartile, UQ, minus the lower quartile. The upper quartile is always 3/4 of the total. It's a very similar calculation to calculating the median. The lower quartile is always 1/4 of the total. That's the definition for the upper and the lower quartile. Again, the upper quartile is always 3/4 of the total. The lower quartile is always 1/4 of your total. So if we work out the upper and lower quartiles first, before we read them off from the graph, 3/4 of 80. Again, you can use your calculator to do this if you need to. We'll give you 60. So the 60th value will be the upper quartile. The 1/4 value will be 1/4 of 80, which will be the 20th value. Now, the common mistake is that people work out these two values and they subtract these from each other and they get 40. That's not how you work out the interquartile range. We have to use these values, the 60th value and the 20th value, to actually see what times they correspond to from the graph. So to do the upper quartile, if I go up 60 on the horizontal axis, 60 is up here. If I go across to where it meets my cumulative frequency curve, remember this is the upper quartile I'm calculating, it meets the curve here. If I drop a line going down, again, use a ruler, and I'm going to approximate this. And from my graph and from my curve, that's going to be about 23 minutes. Again, reading off from this graph, each of these little squares is going to be a half. This is 22.5. If I add a half to that, that's going to give me 23 minutes. So the lower quartile time, which is what I'm actually going to be using, is going to be 23 minutes. This is what I actually wanted. You then have to do a similar analysis with the lower quartile. Sorry, this was the upper quartile value, which is 23 minutes. The lower quartile you do in a similar way. This time we go up to the 20th value, which is here. We go across, and then we go down and we read off the value. And from my graph, this is going to be about 11 minutes. So the lower quartile from my graph is going to be about 11 minutes. And the interquartile range is just going to be the difference between these two values. It's going to be 23 minus 11, which gives us 12 minutes. And that's how we calculate the interquartile range. And again, I can just basically label the lines. The top line for the 60th value was the upper quartile. This line here was the lower quartile calculation, LQ. In this question, we're given a linear simultaneous equation, and we're asked to work out the values of x and y. Now, the method we're going to use is called the elimination method, and we're going to split our simultaneous equation into columns. So first of all, we've got the x column. So I'm just going to draw a little line going across like that. Then I've got the y column, and then I've got the number column. So effectively, I've got three columns: the x column here, the y column here, the number column. The important thing to realize first is that the number in front of the y in the second equation, if there's nothing there, there's a hidden 1. So this is actually 1y. Now, with the elimination method, to make things simple, we are always going to get rid of that middle column. So we're going to get rid of this middle column. And in order to get rid of it, we need to make the numbers in front of the y the same. And there's a very, very simple way we can do that. Because we've got a 3 on the top y, we multiply the whole of the bottom equation by 3. So we're going to multiply the whole of the bottom equation by 3. Because we have a 3 on the top y. Because we've got a 1 on the bottom y, forget about the sign, you don't need to worry about the negative sign just yet. Just look at the number in front of the y. Because there's a 1 here, we're going to multiply the whole of the top equation by 1. So we're going to do that multiplication first. So if I multiply the whole of the top equation by 1, I'm going to get the same equation. 7x, so just to go through it, 1 times 7x will be 7x, 1 times 3y will be plus 3y, equals, and then 1 times 3 will be 3. Now you need to remember you're multiplying everything on the left-hand side and the right-hand side of the equal sign by 1. We then do this multiplication for the second equation. We're multiplying everything in the second equation here by 3. So 3 times 3x will give us 9x. 3 times minus 1 will give us minus 3y, equals, and again we have to multiply everything on the right hand side of the equation, so we need to multiply this 3 by 7. That's going to give us 21. If I draw my column lines in, so I've got my x column, I've got my y column, and now what you're going to notice is that with the y column here, the numbers in front of the y are both the same. However, they've got opposite signs. This is plus and this is minus. If we have a situation where we have opposite signs, what we do is we add the two equations together. So we can make a little note here. Opposite signs means we are basically going to add the equations together. So what I'm going to do, I'm going to put a big plus sign here. I'm going to draw a horizontal line to indicate I'm doing an addition. And the way we do the addition, we do it column by column. So in the first column, 7x plus 9x will give us 16x. Now when you add the second columns together, because you've got a plus and a minus, plus 3y plus minus 3y will be 0. They disappear. The y terms disappear, or you've eliminated them. We then have to add the column after the equal sign. 3 plus 21 will give us 24. So we now have an equation. 16x is equal to 24. To get the x on its own, bring the 16 over. X will be equal to 24 divided by 16. You can then work that out on a calculator. 24 divided by 16 will give us 1.5. That is our first solution. So we now know that x is equal to 1.5. Now remember, we have to work out the y value as well. So I'm going to draw a column line to separate out my work. And to work out the y value, so to calculate y, we're going to use one of the original equations. So I have a choice. I can either use 7x plus 3y equals 3, or I can use 3x minus 1y equals 7. It's easier to use the equations where you're just dealing with positives. So I'm going to use the top equation here, and I'm just going to copy it down. 7x plus 3y equals 3. Well, we know what x is. We know that x is equal to 1.5. So 7 times 1.5 plus 3y equals 3. Right, 7 times 1.5, if we work that out, that's going to give us 10.5 plus 3y equals 3. We can then solve that equation, bring the 10.25 over to the other side. So it becomes a minus. So we end up with 3y equals, now we can work this out. So on the right hand side, we're going to have 3 take away 10.25. That's going to give us 7.5. And then we can bring the 3 over. So y will be equal to 7.5 divided by 3. That's going to give us 2.5. But I need to put the negatives here, which I forgot to do. Right, just remember that 3 take away 10.25 is minus 7.5, not plus 7.5. And then y will be equal to minus 7.5, take away 3, divided by 3 rather, so giving you a y value of minus 2.5. So our two solutions are basically x is equal to 1.5, and then we have y is equal to minus 2.5. This question is a fairly difficult rearrangement that you have to do simply because the right-hand side is this fairly complex algebraic fraction which contains a square root. So we start by just copying down the equation. Now remember, we're going to start working in columns, so I'm going to draw a column line to separate out my work, just to make it a little bit neater. Now the first thing you need to do is we need to get rid of the square root sign here. So I'm going to bring the square root sign over to the left. The opposite of square rooting is squaring, so when that square root moves over, the left-hand side is going to become y squared. So you can see by moving that square root to the left, it becomes a square. So we're going to have y squared on the left-hand side. That's going to be equal to 3x minus 2 over x plus 1. I'm going to put the x plus 1 in the bracket because what I'm then going to do is get rid of the algebraic fraction by moving this whole bracket, the whole denominator, over to the left-hand side. So I'm going to shift that over. And when I do, that division is going to become a multiply. So on the left, I'm now going to have y squared bracket x plus 1 equals 3x minus 2. So I've got rid of the algebraic fraction. Next step, multiply out the bracket on the left-hand side. So y squared times x will be y squared x, and then y squared times 1 will be y squared equals 3x minus 2. Now, when you come to rearranging an equation or making something the subject, in this case x the subject, we follow the same steps as solving an equation. So because we want to get the x on its own, we want to bring all the x's to one side. So what I'm going to do is I'm going to bring this plus 3x over to the left. And at the same time, I'm going to bring this plus y squared term, because it doesn't contain an x, over to the right. So on the left, we're now going to have y squared x minus 3x equals minus 2 minus y squared. And what I'm going to do is I'm just going to copy this expression and I'm going to paste it on the right-hand side. So what I've done is I have this expression y squared minus x minus 3x equals minus 2 minus y squared. Now, the trick to getting x on its own, because both of these two terms have an x in them, we're going to factorize it. We're going to factor out the x. We're going to take the x outside a bracket, and it's a simple factorization. We're going to pull the x outside the bracket, and inside the bracket we're going to have y squared minus 3 left behind equals minus 2 minus y squared. The final step is then to bring this whole bracket y squared minus 3, which is basically being multiplied by that x, over to the right-hand side. So what we're going to be left with is the x on the left minus 2 minus y squared all over y squared minus 3. And that is our rearranged equation with x as the subject. given raw data like this, working out the median, the interquartile range, is fairly straightforward. The first thing you need to do is you need to make sure that your data is put in increasing order. So you can see that the data starts at 2 and then it goes up to 18. The values have already been put in order. The first thing to do is to pick out the middle value. Now, because we've got 15 people, the value that's going to be in the middle is going to be 8. In other words, we've got 7 values on the left-hand side and we've got 7 values on the right-hand side. So the middle value, remember, is the median. So the median is going to be 8. Now, because we've got one value in the middle, if we basically just look at the left-hand side of our data here, we've got 7 values. The value which is in the middle of these is 4, and that's what we call the lower quartile. So the lower quartile is going to be 4. If we look at the upper half of our data, namely these values here, the value which is in the middle of the upper half is going to be 13, and that's what we call the upper quartile. So we know that the lower quartile is 4, we know that the upper quartile is going to be 13. The interquartile range is just the difference between the upper quartile and the lower quartile. In other words, it's the upper quartile minus the lower quartile. That's going to be 13, take away 4, and that's going to give us a value of 9. So our interquartile range is going to be 9. In this example, we have a double bracket, x plus 2 times 3x minus 4, being multiplied by 5x. When we expand and simplify this type of expression, we're going to get a cubic equation where we have an x squared term. Now, it's always slightly easier to start with a double bracket or start with the 2 brackets which are to the far right. So the first thing I'm going to do is I'm going to multiply out the x plus 2 times the 3x minus 4. This is a normal double bracket, so if I multiply this out, 3x times x will give me 3x squared. X times minus 4 will give me minus 4x. And then if I multiply the 2 by the 3x, I'm going to get 6x. And then plus 2 times minus 4 will give me minus 8. If I collect up the like terms, I can't do anything with the 3x squared. That's going to be 3x squared. Minus 4x plus 6x are the like terms. If we add them up together, we're going to end up with plus 2x. And then we're going to have minus 8 at the end. I'm going to put that in a bracket. And then I'm going to bring down the 5x, which was the term at the very, very beginning. Now, what I need to do is I basically need to multiply out this expression or this bracket. So I'm just going to move it over to the right. Now, if I move this expression to the right and if I multiply it out, 5x times 3x squared will give me 15x cubed. 5x plus 2x will give me plus 10x squared. And then 5x times minus 8 will give me minus 40x. And that is my expression expanded and simplified. There aren't any like terms which I can further simplify with, so that is going to be the answer to my expansion. Part B in this question is a powers and indices question. Here we're given this bracket which is raised to the power of minus 3/4. The first thing to note is that we have a negative power up here, and the way that we deal with a negative is we can get rid of it by flipping the fraction inside the bracket. So the first thing we need to do is we're going to flip the fraction inside the bracket, and we're going to get rid of that negative power. We're going to take that negative power and get rid of it and make it into a positive power. So what the negative power does, it flips everything in the bracket. It flips the fraction upside down. Now we can basically do the top and the bottom separately when we want to simplify this term. So the first thing to do is to look at the y to the power of 20 in the numerator, which is raised to the power of 3/4. Now, when you have a power raised to a power, that's indicated by the bracket that you have here, we multiply the powers together. So 20 times 3/4, we can do that on a calculator, that's going to give you 15. So on the top, you're going to have y to the power of 15, because we're multiplying the 20 by the 3/4. To do the denominator, we do the same thing. We're going to start off with the w. So in the denominator, we've got w to the power of 8 raised to the power of 3/4. We multiply the powers together, so we need to multiply that 8 by that 3/4. So 8 times 3/4 is going to give us 6. So on the w, we're going to have w to the power of 6. Now, we have to be careful when we're dealing with the 16. Now, the 16 is not a power. It's just a normal number. So we need to work out 16 to the power of 3/4 on the calculator using the power button. Now, if you work out what 16 to the power of 3/4 is on a calculator, that's going to give you 8. So it's not 16 times 3/4, it's 16 to the power of 3/4. Now, just as a recap, you will need to use the power button on your calculator. So you'll need to use this button on your calculator to actually work it out. So 16 to the power of 3/4 will give you 8. So our final answer is going to be y to the power of 15 over 8w to the power of 6. And that's our simplified expression. Question 13 is basically involving simple powers and indices. The first example is fairly straightforward. These questions are worth 1 mark each, so you really don't need to show that much working. The first example, you got 3 to the power of 4 times 3 to the power of 5. Now, when we multiply terms together, if they have the same base, in this case the base is 3, we just add the powers together. So our answer is just going to be 4 plus 5, which is 3 to the power of 9, which basically means m is going to be 9. In the next example, we've got 5 to the power of 3, and that's all raised to the power of 7. If we see a situation like this, we multiply the powers together. So this becomes 5 to the power of 21. How do we get to 21? We just multiplied the 3 and the 7. 3 times 7 will give us 21. So in this example, n is going to be equal to 21. If we have a slightly more complex example, we do the numerator first because we have numbers on the 7 in both cases. So on the top, 7 to the 8 times 7 to the power of 2 becomes 7 to the power of 10 over 7 to the power of p. That's equal to 7 to the power of 6. So to recap, how did we get the 10? We added the 8 and the 2 together. Now to work out the value of p, well, remember that when we divide, we're taking away the powers. So 10 take away something must equal 6. So we need to remove 4 from 10 to get 6. So p has got to be equal to 4. You can write it as a simple equation if you want. You can write it like this. 10 minus p equals 6. If we then solve this equation, 10 take away 6 will be equal to p, which gives you p is equal to 4. You don't need to do all of this working. You can do it by observation and get the answers straight away. Graph questions like this, where you're given an equation, you're asked to fill in a table of x and y values, and then you're asked to plot the graph on the grid, are very straightforward. It's just substitution. So the first thing we need to do, we need to work out the value for y when x is equal to minus 2. So what we're going to do, we go to the equation, and wherever we see an x, we replace it with minus 2 in a bracket. So minus 2 squared minus 4 bracket minus 2 plus 3. Again, you can do all of this calculation in your calculator. If you type all of this into your calculator in one go, you're going to get a value of 15. So when x is equal to minus 2, y is going to be equal to 15. You then basically have to use your calculator. Don't delete this line that you've typed into your calculator. All you need to do is use the replay button, and wherever you put a minus 2, change it to the next value of x in the table. The 1, the 2, and then the 4. If you use your calculator to work these values out, you find that when x is equal to 1, y is equal to 0. And when x is equal to 2, y is equal to minus 1. And then finally, when x is equal to 4, y is equal to 3. Once we've got the table filled in, the next point is to plot these points on the graph paper below. Don't get put off by this statement where it says values of x from minus 2 to 4. It's just referring to the range of values on the x-axis. You're going from minus 2 all the way to 4. Plotting the points on the graph are fairly straightforward. When we plot coordinates, we have the x coordinate followed by the y coordinate. So if I wanted to plot this point minus 2, 15, I go minus 2 across the x-axis, and then I go 15 all the way up. So the first coordinate, minus 2, 15, is going to be up here. The next coordinate, I'm going to minus 1 across, and then I'm going 8 up, which takes me to here. The next coordinate, I'm going 0 across, 3 up, which takes me to that point there. The next coordinate, I'm going 1 across, 0 up, so I'm going to be here. The next coordinate, I'm going 2 across, and then I'm going down minus 1. Next coordinate, I'm going 3 across, and then I'm going up 0, so it'll be positioned exactly here. And then the last coordinate, I'm going 4 units across, and I'm then going 3 units all the way up, which takes me to this point here. So I get a series of points, and you can see they form a smooth curve. All the points are lying on a smooth curve. You just need to join those points up with the smoothest possible curve that you can actually draw. So roughly it's going to look something like that. And that gives me a quadratic curve, and just as a note, these quadratic curves are called parabola. And a parabola is basically a quadratic curve. In this question, we are given the price of a litre of petrol in January 2007, which is 87.3 pence. And we're told that the litre of petrol in January 2012 has gone up to 133.3 pence. The question is asking us to calculate the percentage increase from January 2007 to January 2012. The first thing you do, work out what the actual increase is. That's going to get you 1 method mark. So we just take the difference between the two prices. 133.3 minus 87.3. And if we work that out on a calculator, we're going to get 46 pence. 46 pence rather. So that's what the increase is. We then need to convert that to a fraction. Now, we always use the original value as the basis of the conversion. So we need to ask the question, we need to write 46 pence as a fraction out of the original, which was 87.3 pence. Now remember, out of simply means a divide, so I can write this statement 46 out of 87.3 as the fraction 46 over 87.3. And to convert a fraction to a percentage, you just multiply by 100. You do all of that on your calculator in one go. and you will end up with a value of 52.691%. Now, if you look at the question, we want this to three significant figures. So if we look at the significant figures, 5 is the first significant figure, 2 is the second significant figure, the 6 after the decimal point is the third, and then we have the 9, which is the fourth significant figure. So because the fourth significant figure is bigger than 5, that 6, which it's next to, has to go up by 1. So the three significant figures, this will be 52.7%, which is the answer that they require. The next example here is what we call a type 2 percentage. And the reason it's called a type 2 percentage is because we're working backwards. If you look at the information that we are given in this question, we're told that the price of petrol increased by 20% from January 2010 to January 2012. We know what the price of petrol was in January 2012. It's 133.3 pence. We're asked to go backwards in time and work out the cost in 2010. So the way we do this, we can make a little diagram to envisage what we're going to do. So in 2010, we don't know what the price of petrol was. We're going to call it X. But from 2010 to 2012, we know that the price of petrol increased by 20%. And we know that the price of petrol in 2012, we have it up here because it's still part of the same question. So the price of petrol in 2012 is going to be this 133.3 pence. Now, when we're doing any type of percentage question, the original value that we start with, in this case, the 2010 value will be the original value. We're going to make that 100%. We always make the original value 100%. So we know that going from 2010 to 2012, the price of petrol, which we call X, increased by 20% to give us this new value of 133.3 pence in 2012. So we can make a little equation. So if I increase the original amount of 100% by 20%, I'm going to get 120%. Now I know that 120% can be written as a fraction. 120% is 120 over 100. Now, if I multiply that by the original amount, X, which I don't know, I'm going to get the new price of petrol in 2012, which is the 133.3 pence. So what I've done is I've taken the original amount X, which I don't know, I'm multiplying it by this fraction 120%, which is 120 over 100, and I'm getting the new value of 133.3 pence, which is a 2012 value. Now, all I need to do is just solve this equation. So I'm going to do it step by step. X times, well, 120 divided by 100 is just going to give me 1.2. So X times 1.2 must be equal to 133. I can then solve that equation. I can bring the 1.2 over. So remember, this is a multiply by 1.2. When it goes over, the opposite of multiply is divide. So to get X, which is the price in 2010, I'm going to take the 133.3 and I'm going to divide it by 1.2. And if I work that out, I end up with 111.08 pence. This is what I was after. This is what the price is going to be in 2010. Now they want the answer to 1 dp, so if I was to round this to 1 dp, it's going to become 111. The second decimal place is 8, so I need to increase this 0 by 1, so it'll be 111.1 pence, and this is the price in 2010. This is a fairly long-winded question, but in general, when we tackle questions like question 16, start at the top and work line by line going down and see what you can calculate for each line. So if you look at the first line, well, it just tells us that Mary saves for a holiday. We can't do any calculation with that. The next line, in 2020, she saved a total of $720. Well, we can't do any calculations with that. The next line tells us that Mary saves $78 a month in 2021. So we can do a calculation. We can work out the total amount she saved for 2021 by doing a simple calculation. 12 months times $78 will give us a total of $936. That is how much she saved in total in 2021. The total amount of money saved in 2021 was P% more than she saved in 2020. What they're asking us to do here is work out a percentage increase. So we need to work out what the percentage increase has been from 2020 to 2021. So we work out the increase first. So we've gone basically from $720 to $936. So the increase is simply going to be 936, take away 720, which gives us $216. Now, we need to express this $216 as a fraction of the original amount of money, which was $700. So we need to express 216 as a fraction out of $720. So we can write that fraction as 216 over 720. And to convert a fraction into a percentage, we do what we normally do, and we multiply by 100. If we type this whole calculation into the calculator in one go, we are going to end up with the value that we require, which is 30%. So between 2020 and 21, there's been a 30% increase. There's a lot of information to unpack in the next part of the question. We've got a different person this time, Roberto, who's going on holiday, and he's basically got two options. He can either use coupon A or he can use coupon B. Now, the information they're telling you is that in coupon A, he's getting 18% off the cost of the accommodation only. And in coupon B, he's getting 12.5% off the cost of the total holiday, which includes the accommodation and the flights. The other bit of information we're given is that Roberto's holiday, the accommodation is $1,600 and the cost of the flights is $800. We have to basically work out which coupon will give you the best value for money and which coupon is going to be better, coupon A or coupon B. This is a multi-part question, so I'm going to separate it by drawing a column line. On the left-hand side, I'm going to do coupon A. And on the right-hand side, I'm going to do coupon B. So I'm clearly separating out my work just to make it a lot easier. So with coupon A, we're getting 18% off the cost of the accommodation only. The accommodation is $1,600. So we need to take 18% away from 1,600. So the original cost of the holiday is 100%. I'm going to subtract 18% from that. So I'm going to be working out how much I'm going to be paying for the accommodation. So the accommodation is going to be 82% of the original amount of £1,600. So I need to work out 82% of 1,600, so 82 over 100. I put that in a bracket and I multiply it by the original amount, which is $1,600, which is the cost of the accommodation. If I do that on the calculator, I'm going to end up with $1,312. That's just the cost for the accommodation. Now we need to add on the flights, so the accommodation plus the flight, which hasn't changed, that's still going to be $800, will give us the total cost for the holiday. So if we add those up together, the cost of coupon A will be $2,112. That's going to be the total cost of the holiday using coupon A. Now, using coupon B, well, coupon B tells us that we're getting 12.5% off the total cost of the holiday. So the total cost of the holiday will be the accommodation, which is $1,600, plus the $800 for the flights, which will give us a grand total of $2,400. Now I need to take 12.5% of this value. So the original value is 100%. I'm going to subtract the 12.5% from that. And if I do that, I end up with 87.5%. So if I now work out 87.5% of 2,400, I will get the cost of the holiday using coupon B. So 7.5% is 87.5% will be 87.5 over 100. I'm going to multiply that by 2,400. And that will give me $2,100. So what you'll notice is that coupon A, the total cost is $2,112. Coupon B is $2,100. So coupon B is the better option. And Roberto should use coupon B rather than coupon A. In this question, again, work from the top and go down line by line and see what you can calculate for each line. If we read the first line, all we're told is that there are 30 apples in a box. We can't do any calculation with this line. The second line tells us that the mean weight of 30 apples is 120 grams. Now, the way that we translate or interpret that sentence is that each of the 30 apples weighs 120 grams. So we can immediately calculate the total weight of all of those 30 apples by simple multiplication. 30 times 120. If we work that out, we get 3,600 grams. So the 30 apples weigh a total of 3,600 grams. The next line tells us there are 10 apples in a bag. The mean weight of these 10 apples is 95 grams. Again, each of those 10 apples weighs 95 grams. That's how you're interpreting what the mean weight refers to. So the total weight of these 10 apples will be 10 times 95, which gives us 950 grams. So we know the total weight of 30 apples is 3,600 grams. We know the weight of the 10 apples in the bag are 950 grams. To calculate the total mean weight of the 40 apples, well, the total weight of all the apples will be just done by simple addition, 3,600 plus 950. That's going to give us a total weight of 4,550 grams. This is the total weight of the 40 apples. So the mean weight, which is basically the mean weight of the 40 apples, which is the weight of each apple, will be 4,550 grams divided by 40, which gives us a mean of 113.75 grams. So on average, each of those 40 apples weighs 113.75 grams. When looking at this question, there are two key words you need to pick out. First of all, the word histogram, and the second is the phrase frequency density. A histogram is more or less a glorified bar chart, but frequency density is an equation that you will have to learn. Frequency density is given by this simple equation. It's the frequency divided by the class width. Now, the frequency from the frequency table is very clear to identify. It's basically the second column that you have here. The class width, which appears in this formula, is the width of each class. So if you look at your frequency table, these are the classes 0 to 20, 20 to 50, 50 to 100, 100 to 300. These are basically the groups that have been used to construct the frequency table. The class width refers to how wide the interval is. It's basically the difference between 20 and 0, which is 20, the difference between 50 and 20, which is 30, the difference between 100 and 50, which is 50. Just be careful, the class width is not the midpoint. So to calculate frequency densities, we do all the working on the frequency table. So what I'm going to do, I'm going to add 2 extra columns onto my frequency table. One of the columns I'm going to call class width, CW. The second column I'm going to head frequency density. And what I'm going to do is I'm going to start working out the class widths first, and then I'm going to calculate the frequency density. Now, the class width is basically the difference between the upper and lower bounds for each group. So 20 take away 0 will give me 20. That's my first class width. The difference between 50 and 20 is going to give me 30. That's what my second class width is going to be. The third one, the difference between 100 and 50, which is going to be 50. And then the last class width, the difference between 300 and 100, is going to be 200. And then what I do is I work out the frequency density by dividing the frequency and the class width. So in the first instance, 50 divided by 20 will give me the first frequency density, which is 2.5. The next calculation is 90 divided by 30, which is going to give me 3. The next frequency density, it's 120 divided by 50, which gives me 2.4 as the frequency density. And then finally, the last one is going to be 160 divided by 200, which gives me 0.8 as the last frequency density. Now, once I've calculated the frequency densities, which are these values here, we then need to construct the histogram or the bar chart to actually do that. In this case, constructing the histogram is a little bit straightforward because we've already been given the axis here for the frequency density is already scaled up, and we also have a scale for the horizontal axis, which is the area. So if we look at the first bar that we need to draw on the graph, the first bar goes from 0 to 20 on the horizontal axis, and the frequency density is 2.5. Now, if we look at the scale here, we've got 10 little squares from 0 to 50, so 50 divided by 10 will give us 5. So each little square here on the horizontal axis is going to be 5. So from 0 to 20, the 20 is going to be basically 4 squares in, which is there, roughly. So 4 squares in is here. We know that the frequency density from the table above is 2.5. 2.5 is up here roughly, so we can draw that bar in. Ideally, in an exam, you would use a ruler for this, but that's the first bar. The second bar is from 20 to 50. That's got a frequency density of 3, so we can draw that bar in like so. Again, you don't need to shade these in, you can just keep them as they are. The next interval is from 50 to 100, and that's got a frequency density of 2.4. So 50 to 100 is there, 2.4 is just one square underneath, 2.5. That's our third bar. And then the last bar is from 100 to 300. Frequency density is 0.8. So from 100 to 300, 0.8 is about there. And we can then draw in that bar. So what we get is a bar chart effectively, but this is called a histogram because both the x-axis and the y-axis have got numbers on them. It's not a bar chart, it's called a histogram. In this question, we have two written statements. Y is inversely proportional to the square root of x, and x is directly proportional to the cube of t. Before we do anything, we need to convert these written statements into equations. So if we look at the first case, y is inversely proportional to the square root of x, we can write that as y equals, now remember inverse proportion is a divide, so we're going to have k1 over the square root of x. I'm using k1 here to indicate the constant of proportionality, and it'll become clear in a second why we're using this little subscript k1. If we look at the next written statement, we have x is directly proportional to t cubed, and we can write that as x equals k2. Now, indirectly proportional means we have a multiply, so it'll be k2 times t cubed. And again, you'll notice I'm using this little subscript here, 2, to indicate that this is a constant of proportionality that is different from k1 above. So the only reason why I've used the little subscripts is to indicate that these two constants of proportionality, k1 and k2, are different. Now, if you look at the next piece of information we're given, we're told that y is equal to 8 when t is equal to 25. There is no mention of x anywhere in this statement. What that suggests is that we will need to combine these two equations together to get rid of the x. So we're just left with an equation with the y and the t in it. Now, we can combine these two equations together because they both have an x in them. So we're going to do a simple substitution. Now, because this is going to be a multi-step problem, I'm going to draw a column line to separate out my working, going down the middle. The first thing I'm going to do is I'm going to rewrite the first equation, y equals k1 over the square root of x. Now, what I'm going to do is I'm going to replace the x here in the square root with this whole expression here, which is x equals k2 times t cubed. So I can replace the x in the square root with k2 times t cubed. So I'm going to end up with something that looks like this. Y equals k1 over the square root of k2 times t cubed. So now I've got an equation here, which is just in terms of y and t. We've gotten rid of the x. Now we can simplify this expression even more If we recognize K1 and K2 are basically numbers, so we can combine them together, even though this has a square root in it, into a new constant, which I'm going to call C. Now, C I just made up, so I can rewrite this equation as y equals the new constant over the square root of t cubed. So this constant C is basically a mathematical way of representing the K1 and the square root of K2 that we had at the bottom here. Now, because we're told that y is equal to 8 when t is equal to 25, I can now go ahead and work out the value of C by just doing a simple substitution. So I'm just going to get rid of this line, and I'm going to put a new line here. And I'm now going to basically replace the y here with 8, and I'm going to replace the t with 25. So my equation now becomes 8 equals c, which I don't know, over the square root of 25 cubed. I'm going to solve that equation. I'm going to bring the square root of 25 cubed over to the left. So I'm going to get 8 times the square root of 25 cubed. That's going to give me the value of C. If I type in the left-hand side into the calculator, so in other words, if I work out this, I'm going to get 1,000. So immediately I can see that C is equal to 1,000. It's a good idea, double check this on your calculator just to make sure that when you type in 8 times the square root of 25 cubed, you do in fact get 1,000. Right, I'm going to draw another column line. And I'm now going to rewrite my equation. So I'm going to rewrite this equation here now that I know that the value of C is 1,000. So my equation will be y equals 1,000 over the square root of t cubed. Now, there's more to this question because they're now asking us to work out the exact value of t when y is equal to 27. So I'm going to do a substitution. So I'm going to replace the y with 27. And I'm going to get 27 equals 1,000 over the square root of t cubed. Now, I need to solve this equation, so what I'm going to do very quickly is swap the 27 with the square root of t cubed. So I end up with the square root of t cubed equals 1,000 over 27. Right, I'm going to move this up a little bit because I'm running out of space. So I'm going to shift that up there. I'm now going to bring the square root over to the right-hand side. So I'm going to get t cubed is equal to 1,000 over 27 squared. And to get t, I now need to take the cube root of what I have on the left-hand side. So I'm taking the cube root of this 1,000 over 27 squared. If I type all of that into the calculator exactly as I see it, and it's a bit of a handful, so the cube root of 1,000 over 27 squared, that gives me 100 over 9. I can put that as a mixed fraction, which gives me 11 and 1/9, and that's an exact value. This is a classic example of a triple bracket. We have 2x minus 1 times x plus 3 times x minus 5. The general way of doing these, always start by multiplying the last two brackets. And we multiply them out like a normal double bracket. So we'll have x plus 3 times x minus 5. If I multiply this out, I'm going to have x times x, which gives me x squared. X times minus 5, which is going to give me minus 5x. And then 3 times x will be plus 3x. 3 times minus 5 will give me minus 15. If I then collect up the like two terms, which are going to be these two middle terms here in the middle, I can't do anything with the x squared. That stays as it is. Minus 5x plus 3x will give us minus 2x, minus 15. I'm then going to put that expression in a bracket. So x squared minus 2x minus 15. So this is the same expression that we just calculated and simplified. I'm now going to bring that 2x minus 1 down and put it in front. So 2x minus 1. And now I'm going to multiply out these two brackets. 2x times x squared will give me 2x cubed. 2x times minus 2x will give me minus 4x squared. 2x times minus 15 will give me minus 30x. Minus 1 times x squared will give me minus x squared. Minus 1 times minus 2x will give me plus 2x. Finally, minus 1 times minus 15 will give me plus 15. Collecting up the like terms, well, we can't do anything with that 2x cubed. There aren't any other two x cubed terms in the expression. So this basically stays as it is. So we're going to write 2x cubed. If we look at the x squared terms, we got minus 4x squared minus x squared. So minus 4 minus 1 x squared. Remember, there's a hidden 1 in front of that x squared. That's going to give us minus 5x squared. Next, we look at the x terms. Minus 30 plus 2x. So minus 30x plus 2x will give us minus 28x. And finally, the plus 15 at the end, there's no other like terms to it, so we keep it as plus 15. And our expression is 2x cubed minus 5x squared minus 28x plus 15. Part B is the solutions to a quadratic equation. Now, because we want the answers here to three significant figures, it means that the values of x we're going to get are going to be decimals. So that implies that we need to use the quadratic formula. So we need to go to the formula sheet and get the quadratic formula, which is minus b plus or minus b squared minus 4ac all over 2a. Now, if I write my quadratic equation here, the first thing to make sure is that the right-hand side of this equation is 0, and it is. We can solve it directly. A is the number in front of the x squared term, so a will be equal to 3. B in this formula is the number in front of the x term, so b will be equal to 6. And c is the number at the end, just before the equal sign. That's minus 5. Now remember, you need to include the negative sign, so we know that c is equal to minus 5. All we have to do are take these values of a, b, and c. We need to put them into the quadratic formula here, but we need to make sure that we use brackets. So don't try to work anything out as you're doing it. Just do the substitution. So we write x equals, now this is a bit of working that you need to show. Minus is part of the formula. Replace the b in the formula with 6 in a bracket. When we get to the plus minus, use the plus first. Square root sign. Replace the b with 6 in its own bracket with the square outside. minus 4. Now replace the A in the formula with 3 in its own bracket. And we replace the C here with minus 5 in its own bracket. All over 2, and then underneath we have to replace the A here with 3. Again, we put the 3 in its own bracket. You then type this whole thing in one go on your calculator. And if you type all of that into your calculator in one go, you will get 0.633. That's one of the solutions. What you'll then have to do is use the replay button and go back and change that plus sign here to a minus. So if I go back and change this plus sign here to a minus and press the equals button, we are going to get the second value for x, which is going to give us minus 2.63. So once you type it in once, all you basically need to do is basically keep everything the same, but change the plus, which was originally here, to a minus to get the second solution. It's a calculator technique. The quadratic formula, which I've written here, don't try to memorize it. It's going to be given to you in the formula sheet. All you basically need to do is make sure you know how to use it properly. And remember, when we solve a quadratic equation, we are always going to get two values of x. In this question, we're told that Dilip buys a painting for $675. He sells the painting and he makes a profit of 12%. What we're basically doing here, if we want to work out the price that Dilip sells the painting for, we just need to increase 675 by 12%. Now, the standard way of doing it, remember that the 675 is the original value. And we always make the original value, or the value we start with, 100%. That's the general rule. So because we're making a profit, we're going to add 12% to 100, which gives us 112%. And then all we need to do is we need to work out 112% of 675, which was basically our original value. So remember that 112% is a fraction. It's 112 over 100. And all we do is we multiply that fraction by the original value, 675. We type all of this into the calculator in one go, and we end up with a value of $756. And that's the selling price that Dilip made. Part B needs careful reading. Ranika sells a car. She makes a loss of $2,162. The percentage loss is 23%. Now, this value here is not the actual price of the car. It's the loss, and it only represents the loss that's been made. So we need to work out, first of all, the original price of the car before she sells it. So the way we can do that, we can basically say that 23%, which is the percentage loss, is equal to $2,162. We can then work out the value for 1%. It's going to be 2,162 over 23, and that's going to give us a value, when we calculate it, of $94. Now remember that the original price, we always make 100%. So the original is always 100%. So if we know that 1% is equal to $94, then we can say that 100% is going to be 100 times 94, which basically gives us $9,400. That is the original price of the car. Now I'm going to draw a little column line going down. So the question's asking us to figure out, well, how much does she actually sell the car for? So if the original price of the car was $9,400 and she made a loss of $2,162, then the selling price of the car can be calculated by basically just doing a simple subtract. So the selling price is just going to be the original price of the car, which is $9,400, minus $2,162. And if we do that, we are going to end up with a value of $7,238. That is the price that Renuka sells the car for. Part C refers to Lynn buying a computer which had an original value of $1,500. So at the end of each year, the computer depreciates. Depreciate basically means goes down or decreases by 40% every year. So we want to work out the price of the computer at the end of 3 years. This is a classic example of compounding. Usually compounding is like a type 1 percentage, but we're doing it over many years. And it's a very, very easy calculation to do. So we start off by saying that the original value, which was $1,500, is always set to 100%. That's our starting point with a lot of the percentage questions. We always say that the original is 100%. Every year, the original value is decreasing by 40%. So we need to subtract 40% from 100. So 100 minus 40 will give us 60%. Now, what that means is that every year the computer is going to be 60% of its value of the previous year. Now, 60% can be written as a fraction. A percentage is out of 100, so we can write the 60% as 60 over 100. We're going to put that in a bracket. Now, because we are compounding for 3 years, because that's what the question's actually telling us, we're going to raise this bracket to the power of 3, and then we're going to multiply it by the original amount we started with, which was that $1,500. And we can do that whole calculation in one go. And if we type all of this into the calculator in one go, we're going to end up with a value of $324. And that's the value of the computer at the end of the 3 years. If you're ever given a question where they talk about a straight line and they're talking about coordinates and the line going through certain coordinates, in this case 0, 10, 12, and then 10, 4, the question is indicating basically you need to use this equation, y equals mx plus c. You need to be using the general equation of a straight line. Now, the general equation of a straight line, y equals mx plus c, the m in this equation refers to the gradient of the line, and the c refers to something called the y-intercept. So the gradient of a line is conventionally given the symbol m. It's usually written rise over the run. Another way of thinking of the rise and the run, the rise is basically the difference in the y-coordinate between your 2 points. And the run is the difference in the x-coordinate between your 2 points. Now, the 2 points that we're referring to are these 2 points here, 0, 12 and 10, 4. Now, just remember that when we write a coordinate, it's always x first and then followed by y. So the first number is always the x-coordinate. The second number is always the y-coordinate. So if we're going to take the difference in the y-coordinates between our 2 points, we can start with the 12. we can say 12 take away 4 will give us a difference in the y-coordinate. And then the difference in the x-coordinate will be 0 minus 10. So 0 minus 10 is the difference in the x-coordinates. 12 take away 4 will give us the difference in the y-coordinates. If we were to work this out, 12 take away 4 will give us 8. 0 take away 10 will basically give us minus 10. If we work that out, we're going to get minus 0.8. That is the gradient. So the equation of the line now becomes y equals minus 0.8x plus c. That's the first stage of the equation. We now need to work out the value for c. C is the number at the end, and c here is referred to as the y-intercept. Now, to do that, we can use one of the original coordinates, 0, 12 or 10, 4. I'm going to use 0, 12 because we've got a 0 here, and we know that when we have a 0, it's going to make things a bit easier when we do the substitution. So using the coordinate 0, 12, what that coordinate tells me is that when x is equal to 0, y is equal to 12 rather. And what I'm going to do is I'm going to substitute the x into this x here in the equation, and I'm going to replace the y 12, the y here with 12. So what I'm going to get is 12 equals minus 0.8 times 0 plus c. Now, when you work this out on your calculator, minus 0.8 times 0, well, anything times 0 is going to be 0. So I'm going to get 12 equals c. So I've immediately worked out the value for c. And so I can now write the full equation of the line. I can replace the c here with 12. And the equation for my line now becomes y equals minus 0.8x plus 12. And that is the equation for my straight line. We're now asked to work out the equation of a new straight line, which is parallel to the line that we had above, L. But this time, the new line, L, parallel to L, will pass through this new coordinate, 5 minus 11. Now, the key idea here is that basically parallel lines have the same gradient. So any pair of parallel lines will have the same gradient, which basically means they're going to have the same m value. So because we know the gradient of a line, because we've calculated it before, is minus 0.8, the gradient of the new line is going to be the same. It's going to be minus 0.8. So I can now write y equals minus 0.8x plus c. We're going to have a new c value because this is a new line. And we're using, again, the general equation of a straight line that we used above, which was y equals mx plus c. Now, to work out the new c value, we have to use the coordinate that we're given. And the new coordinate basically tells us then when x is equal to 5, y is equal to minus 11. The x-coordinate comes first, the y-coordinate comes second. All we have to do, replace the y in this equation with minus 11, replace the x here with the 5, and we're going to form an equation which we're then going to solve. Minus 11 equals minus 0.8 times 5 plus c. We can work minus 0.8 times 5 on the calculator. That's going to give us 4. So we end up with an equation minus 11 equals minus 4 plus c. We can bring the minus 4 over to the other side, so it becomes a plus 4. Minus 11 plus 4 will give us minus 7. So the new value for c for our equation for for our new line is going to be minus 7. So going back to our equation here, we can replace this plus c with minus 7, and that's going to give us the equation for the new line, which will be y equals minus 0.8x minus 7. And that is the equation of the new line, which is parallel to the line L that we had above. With this ratio and fraction question, like with all other questions which tend to be long-worded, start at the top and work your way down, interpreting each line as you go. If you look at the first line, all we're told is that Peter owns a currency conversion shop. We can't do any calculation with that line. The next line tells us that on Monday, Peter changed 20,160 Rand into a number of different currencies. We cannot do anything with that line. If we look at the next line, we're told that he changed 3/10 of the 20,160 Rand into euros. Well, we can work out the number of euros immediately. So the number of euros, we're going to do the working here, is just going to be 3 over 10 times 20,160. If you work that out on your calculator, you are going to get 6,048 euros. So immediately we now know that he's got 6,048 Rand which have been converted into euros. So the amount of Rand remaining, we can basically do a subtract. So we can take the original amount he started with, take away the amount of Rand that he converted into euros, which is the 6,048. And if we do that subtraction, we're going to get 14,112 Rand. So that's how much Rand that he has left behind. Now, in the next line, we're told that he's changing his remainder of Rand into dollars, rupees, and francs in this ratio. So we need to split this amount, the 14,112 Rand, into the appropriate amounts of dollars, rupees, and francs. So I'm just going to put here dollars, rupees, and francs. So we have 9 parts, which are dollars, 5 parts, which are rupees, and we've got 2 parts, which are francs. Now, it's a good idea to use the word parts when you're doing these ratio questions. So because this is the total amount, we can then work out how much Rand was converted into dollars, rupees, and francs. So the total number of parts, if we add them up together, will basically give us 9 plus 5 plus 2. That's going to give us a total of 16 parts. So 16 parts is equal to 14,112 Rand. We can work out the value for 1 part by just doing a simple division. So if I just move that over there. So 14,112 divided by 16. If I do that, I will get 882 Rand. So I can now work out how much dollars, rupees, and francs I have in terms of Rand. So 9 times 882. That gives me 7,938 Rand were converted into dollars. The number of Rand that were converted into rupees will be 5 times 882. I'm getting the 5 from up here because I know that the rupees consist of 5 parts. We know that each part is 882, so the amount of Rand that was converted into rupees will just be 5 times 882, which gives me 4,410 Rand. And then finally, the number of francs that were converted into, sorry, the amount of Rand that were converted into francs will be 2 times 882, which gives me 1,764 Rand. So now I know the exact amounts of Rand that were converted into the three currencies. 7,938 Rand were converted into dollars, 4,410 Rand were converted into rupees, 1,764 Rand were converted into francs. Now, if we look at the last line, it tells you Peter changed more Rands into dollars than he changed into francs. So all we then basically need to do is work out the difference between the number of Rands converted into dollars and the number of Rand converted into francs. So we just need to subtract these two values from each other. So 7,938, take away 1,764. And if we do that calculation, we're going to get 6,174 Rand. That's the difference between the Rand converted to dollars and francs. With this question, it's extremely important that you recognize that you can use normal SOHCAHTOA to solve this problem to try and work out the angle X here. In order to do that, you need to realize that you've got two right angle triangles. You've got the triangle ABD, this small right angle triangle, and then you've got this larger triangle ABC. We know that they're right angle triangles because we have this 90-degree angle basically at the point A. The first stage is basically to redraw your two right angle triangles separately. So I'm going to draw here the right angle triangle ABD. We know that the 90-degree angle is at A. We know that this point here is going to be B. And we know that this point is going to be D. We can put in the lengths 5 and 9. Now I'm not putting in the units centimeters. It just adds a layer of complexity you don't need to worry about. I'm going to do a column line to separate out my work. For the simple reason is I'm now going to draw the bigger triangle here, ABC, on the right hand side. So if I redraw that triangle, it's going to look something like that. We know that the 90-degree angle is at A, this is going to be B, this is going to be C. Now with the bigger triangle, we know that this length is 9 and we know that this length is 15. Now we're asked to calculate an angle. We want to work out this angle here at X. So we need inverse trigonometry if we want to work out an angle. Now before I do anything, I'm going to redraw the formula triangles for SOHCAHTOA at the top. So we have the formula triangle for sine, which is SOH. We've got the formula triangle for cos, which is CAH. And we've got the formula triangle for tan, which is going to be TOA. Now, the logic behind this problem, we're going to do it in two steps. What we're going to do is we're going to work out the whole angle here first of all. We're going to work out the angle ABC. So we want to work out this whole angle, which I'm going to mark in black. Now, I'm going to work out that angle using this triangle here, which is the angle B in the big right angle triangle. What I'm then going to do is I'm going to work out this angle here in red, this smaller angle, using the first triangle I drew, which is going to be this angle here. So the idea is this: once you basically have those two angles, so if I know what the big angle here is, which is angle B, and I know this small red angle here, which is angle B in the small triangle, if I take them away from each other, I'm going to be left with this angle X. So we have two right angle triangles here. We've got the small right angle triangle and the big right angle triangle. And what we're going to try and do is we're going to try and work out these angles. I'm going to call this one A, and I'm going to call this one B degrees. So if I label the sides, up, hype, edge, and then hype, up, edge. Now this is the convention of labeling right angle triangles. The hypotenuse is opposite the 90-degree angle. The angle we're trying to work out looks at the opposite side. So you always start by labeling the hype first, then you label the opposite. The third side will be the adjacent side. With this triangle, the length the 90-degree angle looks at is the hypotenuse. We're trying to work out angle B. The length which is directly opposite angle B, or the length that angle B looks at, is the opposite. And then we have A, which is the remaining side. So with the first triangle, we have the opposite and we have the adjacent. Now the only formula triangle that has the O and the A in it is the tan formula triangle. So that's the one we're going to be using. TOA. So we draw the tan formula triangle in. We're then basically going to replace the sides. We know that the O is 5, so we replace the O with 5. We know that the A in this triangle is this 9, so the A here becomes 9. And we just need to remember that the T here stands for the tan of the angle. That's what the T represents, the tan of A. So to get A, we cover up, literally we just cover up the T, and then what we can see is that we're dividing the opposite by the adjacent. This horizontal line is a divide. Now you need to remember that when you cover up the T, rather than writing tan, you have to write tan to the -1. Your calculator will open a bracket for you, and then you just type in 5/9. Now when we do this on the calculator, we're going to put the answer to at least 2 decimal places. We don't want to approximate too much. So when we do this on the calculator, we will get 29.05 degrees. Now remember that to get the tan to the -1, you have to press the shift button and then the tan button to get that tan to the -1. We can now do the same calculation for the second triangle here. This time we have the adjacent side and we have the hypotenuse once we've labeled the triangle correctly. So we have the A and the H. So the only formula triangle that has the A and the H in it is the tan formula triangle. Sorry, not the tan, the cosine formula triangle. So the only formula triangle that has the A and the H in it is cosine A and H. So I can put the values in. So C, we know that the A in this formula triangle is the 9, so the A is going to go on top. We know that the H at the bottom is the hypotenuse, which in this triangle is 15. So we know the 15 goes at the bottom. Also, the cosine is, or the C stands for the cos of the angle. So to get the angle, we have to do cos to the -1, open a bracket, 9/15. If we do that, so shift cos, 9 divided by 15, will give you 53.13 degrees. Again, I'm putting the angle to 2 decimal places. So we have our two angles. We know B is equal to 53.13 degrees. A is 29.05. And as we said before, to get X, we basically just need to subtract these two angles. So the angle X will be 53.13 minus 29.05 degrees. We're going to work that out. And it's only now that we actually start putting our angle to the appropriate degree of accuracy. So we want everything to the nearest degree. So 24.08 degrees will be 24 degrees to the nearest degree, and that is what our final answer is going to be. Now, I haven't put it on the dotted line. It doesn't really matter. You just need to make sure that this is visible and clear for anyone who's marking it. With this question, I'm going to start at the top, analyze the first line, and then I'm going to work my way down, analysing each line as I go down to see if I can make any calculations. If you look at the first line, all we're told here is that Josh buys and sells some books. We can't do any calculations with that line. If we look at the next line, we're told that he buys some books for £4 each. We're told he buys 120 books for £4 each. What I can do immediately is I can work out the total cost of buying all the books. So the total cost, simple calculation, it's going to be 120 books times £4. And if I work that out, that's going to give me £480. So I've analysed the first line. The second line basically tells me that he's selling half of the books for £5 each. So first of all, I'm going to work out half of 120. That gives me 60 books. Now I know that he's selling those 60 books for £5 each, so therefore the selling price is going to be 60 times 5, which is going to be £300. So we now know that he's sold part of his inventory of books for £300. He's bought all the books for 480. Now the number of books that is actually sold for the £5 is 60. We're then told on the next line here that he is selling 40% of the total number of books that he has, which is 120, for £7 each. So we need to work out 40% of 120 first. So 40% is basically 40 over 100 times 120. That's going to tell us how many books he's selling for £7. So 40 divided by 100 times 120 will give us 48 books. And those 48 books are being sold at £7 each, which gives us a total of £336. So I'm just going to highlight that. So £336 are made by these 48 books. Remember, the number up here is the total number of books that is sold for £5. Now, the remainder of the books, or the rest of the books, he's selling for £8 each. Well, the number of books remaining, well, we started out with 120 books. We've sold 60 of them for £5. We've sold 48 of those for £7 each. So the total number of books that remain, and that will be sold for £8, are going to be 12 books. So the amount of money that he's making by selling those 12 books at £8 each is going to be £96. So we know the amount of money that he's made in total. So the total amount that he's sold the books for, so the total selling price, is going to be the £300 plus the £336 plus the £96 that is just made. And if we add them all up together, we get a grand total of £732. So this is the total selling price. Now we know what the total cost for all the books were. It was 480. So to work out the percentage profit, we work out the profit first. The profit is just the difference between the selling price, which is £732, and the amount he paid for the books. So the profit is just going to be that difference, which gives us £252. Now, to convert that to a percentage profit, it's very simple. We always use the original cost price in the denominator. So we want to express this £252 as a fraction, or out of 480. That's the amount we actually paid for the books. So 252 out of 480 can be written as this fraction. 252 over 480. Now, to convert a fraction into a percentage, all we need to do is now just multiply by 100. We can do that whole calculation in one go and get the percentage profit, which gives us 52.5%, and that is the answer that we're going to put on the dotted line over here. In this question, we're told that Josh owns a book valued at £15 on the 1st of May 2019. We're told that the book had increased in value by 20% in the last year, and we're asked to work backwards to work out what the value of the book was in 2018. This is a typical type 2 percentage, so we're trying to work backwards. So the way we're going to do it is we're going to make a little diagram. In 2018, we didn't know what the price of the book is. That's what we're trying to calculate. Now, between 2018 and 2019, the book increased by 20%. Now, you don't need to make these diagrams, but it gives you an idea of what you're actually doing. And we know that in 2019, the book was valued at £15. Now remember that the original value, the value that we start with, is the 2018 value. We don't know what the price of the book was in 2018, but we know that we can set the percentage to 100%. We always make the original value 100%. So what I'm doing is I'm adding 20% to 100%. So the 2019 value is going to be 120% of what the value was in 2018. So what I can do is I can take the 128% and I can write it as a fraction. 120% is basically 120 over 100. If I multiply that by the original value, which was x, which I don't know what it is, that's what I'm trying to calculate. So in other words, what I'm saying is that I'm increasing the original value x by 120%, and we're told what that must equal to. That has to equal the £15 which we were given. So what we've done is we've effectively created a little equation here which we can then solve to work out the value for x. Now to simplify it, we can work out 120 over 100. That gives us 1.2. So x times 1.2 must be equal to 15. And if we solve that equation, bring the 1.2 over, we will get the value for x. It's going to be 15 divided by 1.2. If you work, you are going to get the value for the book in 2018. That gives you £12.5. And that is the value of the book in 2018, and that's your answer. Before we start to attempt this question, the first thing a few things you need to know about probability. First of all probabilities have to add to 1. That's the first thing you need to realize about probabilities. The other thing I'm going to explain as we go along is basically how this probability tree works. So if we start by analyzing the lines one by one, we're told that Nowak is going to play 2 games of tennis. So because he's playing 2 games, we know that there are going to be 2 events. Now, the probability that he wins the first game is 0.7. Now, there are 2 outcomes for each game. Either he's going to win or he's not going to win. So we have 2 events, and each event is going to have 2 possible outcomes, win or not win. Now, we're given some conditions here. If he wins the first game, the probability that he wins the second game is 0.9. That is one conditional probability statement. And then we're told if he loses the first game, the probability that he wins the second game is 0.4. That's the second statement of conditional probability. Analyzing and constructing the probability tree is fairly straightforward. The first thing I'm going to do, I'm just going to draw a vertical line going down. So everything to the left of that line, the 0.7 and the 0.3 are what happens in the first game. Now we're told that he can either win the first game, which is 0.7, or he can lose the first game. This is going to be 0.3. The way that we get the 0.3 is you just have to remember that probabilities have to add to 1. So if I go 1, take away 0.7, I get 0.3, which is this value here. So just remember, the branches of the tree are basically these lines. So in the first game, there are 2 branches because there are 2 outcomes. The probabilities on each branch have to add up to 1. 0.7 plus 0.3 must add up to 1. In a similar way, we can look at the first conditional statement. We're told that if we follow the first branch where he wins the first game, so if he wins the first game, we're basically following this top branch. We then get to this node. Now, everything that happens from here is for the second game. He can win the second game with a probability of 0.9. Now, we need to remember that this branch here and this branch here, the probabilities have to add up to 1. So if this is 0.9, then the probability here has got to be 0.1. And again, the way that we calculate the 0.1, it's going to be 1 take away 0.9, which gives us 0.1. To get the probabilities for the bottom branches, we go all the way back to the beginning and we say, okay, let's say that he loses the first game. We're now at this node here. This is again for day 2, for the second game that we start. We're told that the probability that he wins the second game is 0.4. So we know that this probability is 0.4. Remembering that the probabilities on each branch have to basically add up to 1. If this probability is 0.4, then 1 take away 0.4 will give us 0.6. So we automatically know that the probability on the bottom branch here has got to be 0.6. So what the probability tree shows us overall are all the outcomes that can happen for the 2 games. So if we follow the branches, we can see that Nowak can win the first game and he can win the second game, or he can win the first game, lose the second game. He can lose the first game, win the second game, or he can lose the first game and lose the second game. So in total, we've got, over the 2 games, we've got a total of 4 possibilities or combinations that can actually happen. To answer part B, we just have to find the combination or the root that we want. So it's asking us to work out the probability that Nowak wins both games. So we want to find the probability that he wins the first game and he wins the second game. So we want a win and a win. So we go back to the tree and we find the path that gives us a win on the first game and the win on the second game. Now, when we follow the branches of a tree, we multiply the probabilities as we go along. So to work out the probability of him winning the first game and then winning the second game, we just multiply those 2 probabilities. 0.7 times 0.9. Type that into a calculator. So 0.7 times 0.9 will give us 0.63. Now, because your answers are given in decimals, so your values here are all decimals, we can keep the final answer as a decimal. If you convert it to a fraction, there's absolutely no harm, but your final answer is going to be 0.63. In this question, we're given a series of triangles and we're asked to calculate the length of C to D. Now, the first thing to note is that we've got a 90-degree angle at D, so that gives us a clue that we have to be using SOHCAHTOA or Pythagoras' theorem. So I'm going to redraw the 3 formula triangles at the top. So we have SOH for the sine formula triangle. We have CAH for the cosine formula triangle. And then we have TOA for the tan formula triangle. It's a fairly complex diagram, so we're going to try and break down and look for different right angle triangles. You can immediately see two right angle triangles. You've got the smaller right angle triangle ACD, and you've got the bigger right angle triangle ABD. So the first thing I'm going to do is I'm going to redraw these two triangles separately. I'm going to draw a column line in to separate out my work, just to make things a bit neater. On the left hand side, I'm going to draw the smaller triangle, ACD. And I'm going to mark in the angle here as D. This is A, and this is C. This is 8 centimeters. Now, we don't know what this angle here is. We don't have any information other than this is 8 centimeters from A to D. And the length we're trying to calculate is this length, C to D. Now, looking at this triangle, there's really nothing that I can actually calculate because I've only been given this length from A to D. I'm then going to redraw this big right angle triangle ABD. So if I redraw that triangle here on the right, I'm going to have my right angle triangle like that. We know that this angle is again 90 degrees at D. We know that A is here. That's going to be 8 centimeters. We know that B is here. And this time we know that A to B is 14 centimeters. Now, in order to calculate the length X, you need to be using this triangle ACD. And I've only been given one length. If there was some way that I could figure out what this angle here is, I can then use trigonometry to work out angle X. Now, what you can look in the diagram and see is that this angle here is 38 degrees. Now, if you look at the triangle ABC, this is not a right angle triangle, so don't be tempted to make this 90 degrees. We can use this angle here, though, to work out this smaller angle here, which is this little angle here. And the logic behind it is that we can use the big triangle ABD to work out this large angle here, which corresponds to angle A in this triangle. And I can use trigonometry. Let me call this small a. I can use trigonometry to work out what this little angle A is using inverse. So this is my hype. Remember, the hype is opposite the 90 degree angle. So the 14 centimeters is the H. The length which the angle looks at is the opposite side. So this is the O. And then the third side has to be the adjacent side. Now, because I'm given the A and the H, the only formula triangle here that has the A and the H in it is the cosine formula triangle. So that's the one I'm going to be using. So if I basically redraw that triangle here, and I can replace what I know, well, C is the cos of the angle. So this C here represents the cosine of this angle. On the top here, we have the adjacent side, which is this 8. So on the top, I'm going to put 8. At the bottom here is the hypotenuse, H, and that corresponds to 14 from the diagram. So at the bottom here, I'm going to put 14. Now, because I want to work out the angle, cos A, and I want to work out the angle A, I'm going to cover up the cos. And when I cover up the cos, I'm going to write cos to the minus 1, 8 over 14. You can do that on your calculator. So the inverse cos of 8 divided by 14 will give you 55.15 degrees. So I now know that this red angle here is 55.15 degrees. Now that angle is the whole angle. Now if I want this little angle here, which I'm marking in the diagram, this little red angle, which corresponds to this angle here, to get it, all I need to do is subtract. I need to take away 38 degrees from this 55.15 degrees. So if I work that out, and I take away 38 degrees from it, I'm going to be left with 17.15 degrees. So this little angle here is going to be 17.15. Now again, how did I get it? I just did 55.15, take away 38, gives me 17.15 degrees, which is basically this angle here. If I now look at this smaller right angle triangle, I'm in a position to work out x. If I label the sides, the length which is opposite the 90-degree angle is the height. So that's the height. The length opposite the angle I'm using, in this case 17.15 is the angle. The length directly opposite that angle is the opposite side, O. The third side is going to be A. Now, looking at the triangle, I'm given the adjacent. I want to calculate the opposite. So A and O is what I'm looking for in my formula triangle. The only formula triangle that contains the O and the A in it is the tan, so that's the one I'm going to be using. So I'm going to redraw my tan formula triangle here. I'm going to put in the lengths. The T is the tan of the angle. So here at the bottom, I'm going to write tan 17.15. The O goes on the top, the A goes at the bottom. So the opposite side is x, that's what I'm trying to calculate. So on the top, I'm going to have x. At the bottom, I'm going to have the adjacent side, which is the 8, which is this length here. Now we cover up the x, and when we cover up the x, you can see that these two are next to each other, so we're going to be multiplying them together. So x, which is the length of C to D, is going to be tan 17.15 times 8. Again, you can do all of that on your calculator in one go. And if we do that, we'll get a value of 2.4687, etc. Now they want this to significant figures, to three significant figures. The first significant figure is 2. The second significant figure is 4. The third significant figure is 6. We need to look at the fourth significant figure, which is 8. Because this value 8 is bigger than 5, we need to increase the 6 next to it by 1 unit. So to three significant figures, our answer is going to be x equals 2.47, and that is the value of the length of C to D. So our answer is just going to be 2.47 centimeters to two significant figures. When you start any kind of question regarding polygons, especially regular polygons, the most important formula you need is the sum of the interior angles. Now there's a formula for working out the sum of the interior angles. It's 180 times n minus 2. The n is basically the number of sides in your polygon. This is probably the most important formula that you're going to need when you come to tackling polygon questions. It's going to save a lot of time. Now, the other thing you need to recognize with this question is that this word show, the word show in the maths that you're going to be doing basically means prove. So you are asked to prove that this angle here, x, is the same as this angle here, y. Now, your starting point, try working out angles. Don't focus your attention on x and y. So the first thing we're going to do, we're going to work out the interior angles of the 10-sided polygon. So in other words, we're going to try and work out what these angles here are. These are your interior angles of your 10-sided polygon. So we can use the formula above. So because we know that we've got 10 sides, we can work out these interior angles. And the sum of the interior angles is given by that formula that we had here at the top. Now, this is going to be a multi-step problem. So the first thing I'm going to do is I'm going to just draw a line going down the middle to separate everything out. So I'm going to start with this polygon here on the right hand side, which I'm just going to highlight. I'm going to start with this big polygon, the 10-sided polygon, to try and work out what those interior angles are. So we know that the formula for the sum of the interior angles is 180 times n minus 2. With the 10-sided polygon, n is equal to 10, so the sum of the interior angles will be 180 times 10 minus 2. If we work that out, that's going to give us 180 times 8, which is 1,440 degrees. Now that's what all of these interior angles are going to add up to around the polygon. So to work out the size of one of the interior angles, we just need to take that value and we need to divide it by 10, which gives us 144 degrees. So we know that these interior angles in the polygon are basically 144 degrees each. Now, we're next going to focus our attention on the the polygon rather, on the left-hand side here. We're going to look at this polygon here. Because by looking at that polygon on the left-hand side, we're going to see whether we can work out what this little angle x is and get a value for that. Now, because of symmetry, remember this is a regular polygon, this is going to be a symmetrical shape. So the angle here at the bottom, this little angle here, is going to be the same as x. You can see that just by the symmetry of the polygon. We know that each of these interior angles is 144 degrees. Now, if we look at the green highlighted polygon here, well, it's got 1, 2, 3, 4, 5 sides. So we've got a 5-sided polygon. We can work out what all of those interior angles of that polygon must add up to. So this polygon here has got 5 sides in it. So if I apply the same formula that I had above, the sum of the interior angles will be 180 times 5 minus 2. If you work that out, you are going to get 540 degrees. So all the angles basically in that green polygon here have to add up to 540 degrees. So I can now work out what x is. So I can write a little equation, 144 plus 144 plus 144, because I've got 3 interior angles, plus 2x, because I've got this x here, I've got that x, and I've got that x. These 3 angles here are all 144 degrees. Let me mark that in. All of those angles have to basically add up to 540 degrees. I can then solve that equation. 144 times 3 will give me 432, plus 2x must equal 540 degrees. I can then work out 2x by subtracting 432 from 540, which gives me 108. And then I can work out what x is just by dividing 108 by 2, which gives me 54 degrees. So immediately I now know, and I have a value for x, which is basically equal to 54 degrees. And the way that I calculated it was, just to recap, I looked at the big 10-sided polygon, and I worked out what the interior angle was using this formula here. I then looked at the smaller 5-sided polygon on the left-hand side, and I worked out what x was, because I was able to figure out that the interior angles would add up to 540 using the same formula. In order to answer this question, now that we know that x is equal to 54 degrees, we need to prove that y is equal to 54 degrees as well. Now to do that, we're going to look at this polygon on the right hand side here. Now this is a four-sided polygon. I'm just going to highlight it in yellow. And what I'm going to try and do is I'm going to try and figure out what this little angle here is in that polygon. So I want to try and figure out what this angle here is. Now by symmetry, we also know that this angle here is going to be the same as this angle here. So these two angles, because of symmetry, are going to be the same. I'm going to call those two little angles B. Now, this angle is again 144 degrees because we calculated that right at the beginning. This applies to the 10-sided polygon. So these are the interior angles of the polygon that we calculated at the very start. So because this is a four-sided shape, the sum of the interior angles for this four-sided shape, we can use the same formula that we had before. 180 times n minus 2. We've got four sides, so 180 times 4 take away 2. That gives us 360 degrees. So with this polygon that we have here on the right-hand side, we know that all of these interior angles have to add up to 360. We know that these two angles have to be the same because of symmetry. So we can make another equation. We can write 144 plus 144 plus b must equal 360. If I simplify up that expression, 144 plus 144 is 288, plus 2b must be equal to 360. If I then solve that equation, I will get 2b is equal to 72 degrees, and I will get b as being equal to 36 degrees. And we're nearly there in terms of calculating the value for y. So we know that b must be equal to 36 degrees. We also know up here that we've calculated that x is equal to 54 degrees from the previous bit of working. So we know this angle here, and we know that this angle there is 36 degrees. So if I just focus my attention on this area here, we know that the interior angle of the 10-sided polygon is 144 degrees. We calculated that at the beginning. So what we know is that x plus this y plus that b must all add up to 144 degrees because that will be the interior angle of the 10-sided polygon. We know that x is already 54 degrees, and we already just calculated that b is 36 degrees. So to calculate y, we can make a little equation. We can say that x plus y plus b must equal, sorry, I'm just going to shift this over underneath. We can say that x plus y plus b must equal 144 degrees. The 144 degrees is the interior angle of the 10-sided polygon. We know that x is equal to 54 degrees. We don't know what y is. We know that b is equal to 36 degrees because we just calculated it here, equals 144. If we then solve this equation to get y, we're going to be subtracting 54 and 36 degrees from 144. And if we work that out, 144 minus 54 minus 36 will give us 54 degrees. And what you've just done is you've just shown that x must be equal to y. And both of those values are equal to 54 degrees. And that is the proof. It's a little bit long-winded. It's a full marker. The general idea is that whenever you do any questions with polygons, use this formula, or that should be your starting point. Work out interior angles. That'll get you method marks, and it'll give you a good starting point as to how to proceed with the question. On the surface, this looks like a fairly tough circle theorem question. You've got this fairly complex shape. The O, remember, is the origin or the center of the circle. In order to tackle this question quickly and efficiently, you need to use your imagination a little bit, and you need to imagine this point here, M, on the circumference of the circle, moving. So we're going to imagine that this point M moves to, say, somewhere here. The reason we're going to do that is because we're then going to see clearly which circle theorem that we're going to be using. Now, if the point M moves to this point here, the lengths are going to stay attached to P and L. So the diagram that we're going to end up with, it's going to look something like this. We are going to end up with a circle. Its center is going to be here. That's O. The points L and P will basically still be the same. So this will be P and this will be L. But the point M is now going to be here somewhere. So it's going to be there. And if I just redraw this diagram and connect M to P and then M to L, the diagram that I'm creating now should look more familiar. This is the typical diagram of the arrowhead. And the arrowhead circle theorem basically links this angle here at the circumference with this angle here at the origin. Now, the important thing to remember is just because I move the point M to a different point of the circumference, this angle is not going to change. So this angle at 48 degrees here is still going to be 48 degrees in the new diagram that I've made. So this is going to be 48 degrees. Now the circle theorem linking the angle at the origin to the angle at the circumference is that the angle at the origin is twice as large as the angle at the circumference. So the angle LOP is simply going to be 2 times 48, which gives us 96 degrees. That's the angle. The reason is the angle at the origin equals 2 times the angle at the circumference. So you'll notice I'm using the angle symbol. And we just need to write for the same arc. And that's our reason. There is a lot of information given in this diagram and in the actual question itself. The first thing to note is that this line ATB is a tangent line. It's a tangent because it just touches the circle at the point T. So that's the first thing to note. The other thing to note is that look for shapes like cyclic quadrilaterals. So immediately you should be able to spot that you've got a cyclic quadrilateral here. A cyclic quadrilateral is basically a four-sided shape where each of the corners have to touch the circumference of the circle. Now, a general rule, don't focus on the angle that they're actually trying to ask you to calculate. So they want us to work out this angle STA. They want this little angle here, but don't focus your attention on that. Try and work out other angles and as many angles as you can without focusing on the angle STA. Now, with cyclic quadrilaterals, and once you've spotted that this is a cyclic quadrilateral, with cyclic quadrilateral, the opposite angles have to add up to 180 degrees. So these two angles, which are directly opposite each other, the 73 degrees here and this angle here, have to add up to 180 degrees. So that's the theorem. So if this angle here is 73 degrees, to work out this angle here, all I have to do is basically go 180, take away 73. If I work that out, I am going to end up with 107 degrees. So immediately I know that this angle here is going to be 107 degrees. Now, the other thing I can immediately work out is that I've got a triangle here. I've got the triangle SRT. Now we know that the angles in a triangle add up to 180 degrees. I know that this angle is 107 and I know that this angle here is 26 degrees. So I can work out immediately what this angle here is. So if I add that 107 to 26, and then I take that away from 180, I'm going to get 47 degrees. So this angle here at the top is 47 degrees. Now, we need to put reasons for our answers. So the way that we've got the 107 degrees here, we can just write opposite angles in a cyclic quadrilateral or cyclic quad, add together to give you 180 degrees. That's going to give us the reason for how we got that 107 degrees. How do we get the 47 degrees here? Well, that was because angles in a triangle add together to give us 180 degrees. That's the second reason. Now, to work out the angle STA, the angle STA is basically this angle here. Now, whenever we've got a tangent and a chord, the theorem that we need to use is going to be the alternate segment theorem. Now, the tangent is this line ATB, and the chord that I'm going to be using is this chord S to T, because that chord S to T basically defines this angle here, which is what we're trying to find. Now, if I just make a little diagram of the alternate segment theorem, the alternate segment theorem, basically, we've got a circle. Let's say that we've got a chord like that. And let's say that we've got a tangent like that. What we can see is that between the chord and the tangent, we have this angle. So this is the angle here between the chord and the tangent. Now, what the alternate segment theorem basically tells us is that if we draw any triangle on that chord, so if, for example, I drew a triangle like this on that chord, this angle here is going to be the same as this angle here. So the angle between the chord and the tangent, x, is the same as the angle on the triangle that I draw on the opposite side of that chord. So if you look at this diagram that we've got here, you've got the tangent, which is ATB. We've got this chord, S to T. And if I look at the triangle which is drawn on that chord, S to T, it basically corresponds to this triangle here, which I'm going to put in red. It corresponds to this red triangle here. So I'm just going to make that a little bit bolder so you can see it. And if you make a comparison with this red triangle to the diagram that I've got here, you can see that this 47 degrees is going to correspond to this angle here, which I've marked in blue. So this blue angle here is going to be 47 degrees. It's the same as this angle here. So that angle is the angle we're looking for. This 47 degrees is the angle STA. So the angle STA from this diagram is going to be 47 degrees. And the reason is we just say it's the alternate segment theorem. Now, that's a little bit difficult to spot with this diagram for the simple reason there is a lot of information that they're giving you. But with the questions with geometry, don't focus on what they're asking you to calculate. Start by working out the 107 degrees first, then work out the 47 degrees, which was basically angles in a triangle. Eventually, you will get to the angle you want to actually calculate. This is another polygons questions, and with all polygon questions, we are going to start by using the formula for calculating the sum of the interior angles. This should now start to become very, very familiar to you. 180 times n minus 2, where the n here is the number of sides in the polygon. So we've got two polygons. We've got the larger octagon, which has got 8 sides, and then we've got the smaller pentagon, which has got 5 sides. So our starting point, we want to try and calculate the interior angles of each of those polygons. So we want to work out what these interior angles are going to be. So we need to work out that interior angle, and we need to work out the interior angle for the pentagon. So again, if we look at the question, it's going to be multiple steps, so we're going to draw a column line going all the way down to separate out our work. So first of all, we start with the octagon. So with the octagon, the sum of the interior angles, or I'm just going to call it sum, it's going to be 180 times 8 minus 2, because the octagon's got 8 sides. If I work that out, I'm going to get 1080 degrees. And the interior angle, I just need to take that 1080 and divide it by 8. And if I do that, I calculate the size of the interior angle for the octagon as being 135 degrees, which I can put on the diagram. If I now look at the smaller pentagon, same calculation, the sum of the interior angles will be 180 times 5 minus 2. That gives me 540 degrees in total, and the size of one of the interior angles will be 540 divided by 5. That's going to give me 108 degrees. So each interior angle of the pentagon is going to be 108 degrees, and for the octagon, each interior angle is going to be 135 degrees. So 108 degrees and then 135 degrees. So we picked up method marks. Now, if we look at this diagram, the first thing you need to note, this is not a straight line. There's a bend in the line at I, so don't make the assumption that these two angles here add up to 180 degrees. They don't. The trick to this question is to realize that what you're actually dealing with is an isosceles triangle. And how do you know we're dealing with an isosceles triangle? If you look, the pentagon and the octagon basically have the same sides. This length A to B is the same for the pentagon as it is for the octagon. So what that basically means is that in this diagram here, the length from B to I has got to be the same as the length of B to C. So this length here has got to be the same as that length there. So what we have, if I redraw this, is we effectively have an isosceles triangle that looks like that. If I call that B, I, and C, this length and this length are going to be the same. So B to I is this length here, B to C is this length here, and the angle X is going to be this angle I on our isosceles triangle. So this is going to be the angle X. Now, because this is an isosceles triangle, the base angles are going to be the same. So this angle is also going to be X degrees. So all we need to do is we need to try and figure out how to work out this angle here at B. So to work out this little blue angle at B, we note that if I just enlarge it, the whole angle from here to here is the interior angle of the octagon. So we know that this is going to be 135 degrees. We also know that from here to here is the interior angle of the pentagon, which is 108 degrees. So to get this little angle here, we just need to do a subtract. That little angle is just going to be 135 minus 108. And if we work that out, that's going to give us 27 degrees. So this little blue angle here, in black, not blue, is going to be 27 degrees. So this has got to be 27 degrees as well. So I'm going to mark in this angle here as 27 degrees. So the way that I got the 27 degrees is that I subtracted 108 degrees, which was the interior angle of the pentagon, from 135 degrees, which was the interior angle of the octagon. Now, we know that the angles in a triangle add up to 180 degrees, so we can do a simple calculation now to work out the value for x. So these three angles will have to add up to 180. So to get x, it's just going to be a simple case of 180 subtract 27 and then divide that whole result by 2. This is a typical calculation that you will do for isosceles triangles because the base angles are always going to be equal to each other. If I do that calculation, 180 take away 27 divided by 2, I end up with 76.5 degrees. And that is going to be the value for x. Now, just going back to the diagram, it's very, very important to note, don't assume that JIC is a straight line and that the diagram's been drawn incorrectly. You can't make the assumption that that's a straight line. In all geometry questions, if you can try and look for isosceles triangles or equilateral triangles, it's going to make your life a lot easier. This is a rather tricky question involving a quadrilateral. Four-sided shape. Knowing where to begin is probably the hardest bit. If you've got a question like this where you're given lengths and angles and you can't obviously see a right angle triangle, it indicates that you may have to use either the sine rule or the cosine rule, which means that you need to draw an extra line to make a triangle. Now, we note that it's a 6-mark question, so we know that it's going to have multiple steps. So the first thing I'm going to do is just draw a column line to separate out my work down the middle. Now, we have two choices in how we add an extra line to form a right angle triangle. We can either draw a line from M to P, but if we do that, we're basically cutting this angle 58 degrees and this angle 72 degrees into an unknown ratio. The better option is to draw a line between L and N so that we create two right angle triangles here and we keep these lengths and we keep this angle intact. So we have two triangles now, the triangle at the top MLN and the triangle at the bottom LPN. Now, we don't have a lot of information on the triangle on the top. We just got an angle and a length. So we're going to start with this triangle NLP, and we're just going to redraw it on the left-hand side here. Now, one of the things that we can calculate is the length N to L. So we know that this is 15.6. We know the angle is 72 degrees. We know that this length is 4.3 centimeters. We can work out this length using the cosine rule. How do we know that we can use the cosine rule? Because we have two lengths and we have the angle in between the lengths, and the length we're trying to calculate is opposite the angle. Now, the cosine rule from the formula sheet is a squared equals b squared plus c squared minus 2bc cos x. So the first thing I'm going to do is I'm going to label the sides. The length opposite the angle that I'm using, which is in between the two lengths, so the angle is 72 degrees, it's in between 4.3 and 15.6. That is what I'm going to call A. The other two lengths I'm going to call B and C, and it doesn't matter which one I call B and C. So B and C are the lengths on either side of the angle. Now, if I put those values into that formula, I'm going to be working out A. So A squared will equal 4.3 squared plus 15.6 squared minus 2 times 4.3 times 15.6 times the cos of the angle. Well, the angle is 72 degrees. If I then work that out in one go on the calculator, so 4.3 squared plus 15.6 squared minus 2 times 4.3 times 15.6 times the cos of 72. That's going to give me a value of 220.39. Take the square root of that, and you're going to get A is equal to 14.85. And I'm going to keep that to 2 decimal places. So I haven't shown the square root immediately, just to save space, but basically to get from here to here, you have to take the square root. So I'm going to put that information back into the diagram. I now know that this length from L to N is going to be 14.85. So I'm just going to mark that into the diagram, 14.85. Now, the reason why I worked out this length L to N was that it gives me more information now that I can then proceed with the question. So if you look at the triangle here at the bottom, I now have 3 lengths. And that's going to enable me to work out an angle using the cosine rule. On the triangle above, I've also got more information. I've now got 2 lengths and I've got this angle here. Now, if you look at the question, what we're actually asked to find is the angle MLP. So the angle MLP is made up of 2 parts. It's made up of this angle here on the top triangle, and it's made up of this angle here on the bottom triangle. So I'm going to call this A and I'm going to call this B. So what I need to do is basically figure out how I'm going to work out this angle A and then how I'm going to work out this angle B. Now, angle A, well, it involves the small right angle triangle at the bottom, which I've already redrawn here. So that angle I'm going to mark in the diagram and I'm going to call this angle A. Now, to work out that angle, I can basically use the sine rule. It's a little bit easier than using the cosine rule. So to calculate angle A, I'm not going to redraw the triangle, but what I am going to do is I'm going to mark this angle X, because we've just calculated it, as 14.85. So I'm going to put 14.85 here. Now, because I'm trying to work out an angle, I'm going to use the sine rule with the sines on top. Now, remember, the sine rule is basically sine A over little a equals sine B over little b. And I'll explain what the A and the B are in a second, but if we want to work out an angle using the sine rules, the sines have to go on top, or the angles have to go at the top. The little a and the little b are basically the lengths. Now, we look for length angle pairs. So if I look at this diagram here, we have a length angle pair between the angle we're trying to work out and the 4.3. This angle is opposite this length 4.3. That is one length angle pair. So what I can immediately write is sine A, well, I'll use the small case a for the angle, A degrees. The length which this angle is opposite is the 4.3. So at the bottom, I'm going to have 4.3 equals sine B. Now that other length angle pair is going to be between the 72 degrees and the 14.85, which I just calculated. So I've got the length here, the 14.85, and that's opposite the angle 72 degrees. So that's another length angle pair. So I can write sine 72 over 14.85. Now I can solve that equation. I can bring that 4.3 over to the right. And I'm going to be left with sine A, which is the angle that I'm trying to calculate, is sine 72 over 14.85 times 4.3. If I work that out, I'll get the value for sine A. So if I type that into the calculator, sine 72 over 14.85 times 4.3. Now, you're going to end up with a decimal, which is absolutely fine. I'm just putting the decimal to 3 decimal places, but don't delete this from your calculator screen. This is the value for sine A. So to get the actual angle, we need to do the opposite of sine. So we need to take the inverse sine, and I'm going to use the answer button on the calculator. rather than having to type out this whole decimal again, I can use the answer button. If I do that and I go shift sign and then use the answer button on the calculator, I'll get an angle of 15.99 degrees to 2 decimal places. That is the small angle on the diagram above. So this angle here, which is what we just calculated, and that angle is going to be 15.99 degrees. To save some time, I've redrawn this triangle MNL in this space here on the right hand side. The angle I'm trying to work out is going to be this angle here, which I've called angle B. Now again, we can use the sine rule to work out this angle because we have length angle pairs. We have this angle 58 degrees, which is directly opposite the 14.85. That's one length angle pair. The other length angle pair is basically between the 13.7 and the B degrees, which is what we're trying to calculate. So again, we're using the sine rule. We're going to put the sines on top. So we can write sine B over the length, which it's opposite, which is the 13.7, equals sine 58, which is basically this angle here, over the length which it's opposite, which is the 14.85. So the sine rule basically enables you to make an equation which you can then solve to work out either an angle or a length. In this case, what we're trying to work out is this angle B. So we need to move the 13.7 over to the right so it becomes a multiply. So we'll end up with sine B equals sine 58 over 14.85 times 13.7. Okay, if we work that out, we will get sine B equals, and we just type that into our calculator. So sine 58 divided by 14.85 times 13.7. We should end up with a decimal, and we do. It's 0.7823. Again, don't delete it. We're going to use the answer button to get the angle. So we need to take this inverse sine of that value we just calculated, which will give us B, or the angle B, as 51.48 degrees. So what we've calculated now is the angle B. There's one final step, so I'm going to mark the angle B here as 51.48. So the last step in the calculation is to calculate the angle MLP. So I'm just going to draw a line to separate my work. So the angle MLP, we just need to add up the two angles together. So angle MLP is this whole angle here. It's going to be angle B plus that angle A. So I'm just going to write A plus B. That's going to give us 15.99 plus 51.48. If I then add those up together, I'm going to get 67.5 degrees, and that is to 3 significant figures, which is what the question wanted. So our answer is just going to be 67.5 degrees. Put the little degree sign on. And that is our final answer. Now, just a quick note. Although the question says give your answer to 3 significant figures, in the middle of your calculations, keep your answers to 2 decimal places. Only round at the very, very end. If you can figure out how to use the answer button on your calculator, it's going to save you a lot of time as well, because you won't have to retype calculations. If we read this question carefully, what we're given is a straight line, and we're given the equation of the straight line, x minus y equals 3, and we're given a curve with this equation. We can see that we've got x squared and y squared in it. This is an example of a quadratic simultaneous equation. Now, if you look at what the question is actually asking us to find, they want the midpoint of P and Q. Now, P and Q are the coordinates of where the straight line, L, intersects with the curve C. So to work out the coordinates for the point of intersection, we need to solve our quadratic simultaneous equation. So the first equation for L, for the line L, this is our linear equation because this equation doesn't have any squares on it, it's just x and y. The second equation is our quadratic equation because we have the 3x squared term in it and we have the y squared term here. So this is going to be a multi-step problem. If you look at a number of marks, we are getting a total of 6 marks. There's going to be several steps, probably about 6 or 7 steps. So the first thing we're going to do, we are just going to draw a column line going all the way down, just to separate out our work. So I'm just going to move this a little bit to the right. So we start with the linear equation. Step 1, we write down the linear equation, x minus y equals 3. And we have to decide whether we want to make x or y the subject. In this case, it's easier to make x the subject because all we need to do is move the minus y over to the right-hand side, and that becomes a plus y. So we're going to be left with x equals 3 plus y. So we've made x the subject of the linear equation. Step 2, we are going to substitute into the quadratic. So the quadratic equation is 3x squared minus y squared plus xy equals 9. Don't get put off by this quadratic equation. What we're basically going to be doing, wherever we see an x in the quadratic, we're going to replace it with 3 plus y because we know that x is equal to 3 plus y. So we have to replace this x and this x with 3 plus y. So our quadratic equation now becomes 3, and then in brackets 3 plus y squared minus y squared, plus we're going to replace this x with 3 plus y in a bracket, times y equals 9. Now remember that this 3 plus y squared is actually a double bracket, so I'm going to rewrite it as 3 bracket 3 plus y times 3 plus y minus y squared plus 3 plus y times y equals 9. Step 3, I'm now going to basically expand these brackets out here and here, and I'm going to collect up the like terms. But what you'll notice is with this equation here, there are no x's in this equation. We've done the substitution and our equation is now only in terms of y, which means we're going to be able to solve it. So step 4, we're going to expand, step 3 rather, we're going to expand the double bracket. Now before we do anything, we need to multiply this double bracket out. So we're not going to touch the 3 here. We're just going to multiply these two brackets together and keep the 3 outside. So we're going to get 3. And then if I multiply out this double bracket, so 3 times 3 is 9, 3 times y is 3y, y times 3 is 3y, and then y times y is y squared. I'm not going to show all the steps, I'm just going to write it down. So 3 times 3 was the 9, plus the 3y plus the 3y plus the y squared minus y squared. And then if I multiply out this bracket here, y times 3 will be 3y, and then y times y will be y squared again. So I'll have 3y plus y squared equals 9. I can then simplify this square bracket, so I can collect up the like terms here before I multiply by 3. So I'm going to end up with 3 bracket 9 plus 6y plus y squared minus y squared plus 3y plus y squared equals 9. I can now start to tidy things up. I can multiply, first of all, this square bracket by the 3, which is outside. So 3 times 3 will be 27, 3 times 6y, and then 3 times y squared. So if I go ahead and do that, I'm going to end up with 27 plus 18y plus 3y squared. Now, if I look, minus y squared here and the plus y squared here, well, these are opposite signs. These will cancel each other off. So literally, we're going to get rid of that term and that term. And we're just going to be left with plus 3y equals 9. We can collect up like terms again. So we've got 27 we can't do anything with. 18y plus 3y will give us 21y plus that y squared. So we'll end up with 27 plus 21y plus 3y squared equals 9. And now this should be familiar to you because it's starting to look like a quadratic equation. Now, with a quadratic equation, the right-hand side of this equation has to be 0. So we need to bring that 9 over to the left-hand side. So we need to shift that 9 over to the left-hand side so it becomes a minus 9. And I'm going to tidy that up and put that into step 4. So step 4 is basically making the simultaneous equation that we're familiar with. So when we normally write the simultaneous, the quadratic equation, the y squared term usually goes first, then we have the y term, and then we have the number. So I'm just going to rewrite this as 3y squared plus 21y plus 27. Now remember that when that 9 goes over to the left-hand side, it's going to become minus 9 equal to 0. And if I do the final bit of simplification, basically collecting up the like terms here and here, 27 take away 9 is going to give us 18. So our equation, our quadratic equation at the end of step 4 is just going to be 3y squared plus 21y plus 18 equals 0. Now that we've got our quadratic equation here at the end, it's equal to 0, we can now solve it to work out y. And the way that we're going to solve this equation is, in this case, by using the quadratic formula. So what I've written here in step 5 is the quadratic formula. The quadratic formula you get in the formula sheet, so don't try to memorize this. We just need to figure out the values of a, b, and c from this equation. Now, that's what we're going to do first of all. A is the number in front of the y squared term. So basically, a is going to be 3, which is this value here. B is the number in front of the y term, so we know that B is going to be equal to 21. C is the number at the end, so C is going to be 18. Now, there's one little caveat to this. In the formula sheet, the equation is written with x at the beginning. you need to realize that this x is in this equation going to be y because we're solving this equation in terms of y. So I need to replace this x here with a y just to make sure I don't get confused later on between the x and the y's. So this should actually read y because our equation is in terms of y. Now if I put the values of a, b and c into this equation, remember that when you substitute, you just need to do it once. You need to make sure that you're using brackets. So y equals minus, and then b goes in its own bracket. When we get to the plus minus, we start by using the plus first. So plus square root, and then b is 21 squared, minus 4, and then in brackets a is 3, c is 18. All over 2, and then in brackets a is equal to 3. So this is the bit of working that you need to show the examiner. You need to show that the substitution being done correctly. Now, when you work this out on your calculator, remember we're going to get two values because it's a quadratic. So if I type this into my calculator in one go, the first value that you're going to get is y is equal to minus 1. And to get the second value of y, what we need to do is we need to change that plus to a minus. So if we change that plus to a minus, we're going to get another value for y, and that's going to give us y is equal to minus 6. So when we solve this quadratic equation, and again, I'm not doing this explicitly, this is the only bit of working that you need to show, you're going to get two values of y. Y is equal to minus 1, y is equal to minus 6. So those are your two values of y. Now remember, this is not the end of it. We're looking for the coordinates of a point of intersection. So for each of these values of y, we need to calculate the corresponding x coordinate or the corresponding x values. And that's what we're going to do in step 6. Step 6 is going to be calculating the values for the x coordinate. Now, remember, we already have an equation here for how we can work out the x coordinates. We rearranged the linear equation at the very, very beginning. So we're going to use this equation here. Now, going back to what we just calculated, we have two possible values of y. So for each of these y values, we need to calculate x. So when y is equal to minus 1, so we're going to use this value first. We can use this equation to work out x. So we know that x will be equal to 3 plus minus 1. If we work that out, we're going to get 2. So we know that when y is equal to minus 1, x is going to give us minus 2. That's going to be our first coordinate. So when x is equal to 2, I'm going to call this coordinate P, just for reference. You can call it Q if you want, but I'm going to say, okay, P is going to have this coordinate, 2, comma, minus 1. Remember, when we write a coordinate, we write the x first, followed by the y. So we've immediately worked out one of the coordinates. As I said, I call this P. If I wanted to call this Q, I could call it Q. It doesn't really matter. We then need to get the other coordinate. So we know the other value for y was minus 6. So we need to work out the value for x when y is equal to minus 6. We do it in the same way. So when y is equal to minus 6, we can work out its x coordinate using this equation here. So x will be 3 plus minus 6. If we work that out, we will get x is equal to minus 3. So we have the second coordinate. We know that when y is equal to minus 6, x is equal to minus 3. Now, we've already used P, so we can write the second coordinate Q as -3, comma, -6. So we've now got our two coordinates P and Q. We've got P up here, and we've got Q here. The last step of the calculation, which is what they wanted us to work out, was the midpoint of P and Q. So I'm going to draw a separation line, and a quick reminder, to get the midpoint, we have to do a little bit of coordinate geometry, and we need to realize that the midpoint is going to be the mean of the x coordinates and the mean of the y coordinates for our 2 points. So that's how we basically work out the midpoint. A little bit of coordinate geometry that you need to remember. The midpoint is always going to be the mean of the x coordinate and the mean of the y coordinates. Now, because we've got two values, the way to work out the mean of two values is we add them up and we divide by 2. So what I'm just going to do is I'm just going to write the two coordinates here. P is 2 minus 1, Q is -3 -6. So the midpoint, M, it's going to be the mean of the x coordinates, so 2 plus -3 divided by 2. So it'll be 2 plus -3 divided by 2. And then we're going to take the mean of the y coordinates. So we're going to add the -1 to the -6, and we're going to divide by 2. So it'll be -1 plus -6 divided by 2. And if I work those out, so M, so 2 plus -3 will give you -1. -1 divided by 2 will give you -1/2. That's what the x coordinate for the midpoint is going to be. And then if we do the same thing for the y coordinate here, -1 plus -6 is -7 divided by 2. That's going to give you -7/2. Now you can keep your answer in this fractional form like we've done here, or you can put them as a decimal if you like. It's completely up to you. Some people prefer fractions, other people prefer decimals. So this is our answer. So the midpoint coordinates, if I want to put them as decimals, will just be -0.5 -3.5.